Hello there, and welcome to the Deep Rest Science Channel. I'm so glad you found your way here, because tonight, we're going to embark on a tranquil journey through one of the most mind-expanding and mysterious realms of existence, the concept of parallel universes. Let this be your moment to slow down and unwind. Wherever you are, let the rush of the day fade, the noise soften, and your thoughts drift gently, like starlight illuminating the endless possibilities of the cosmos. Tonight, we'll explore the mind-boggling, yet soothing idea of parallel universes. Though they might seem distant or far beyond our reach, they are woven into the very fabric of reality itself, existing just outside our perception, like hidden branches on an infinite tree. As we explore calming facts about these alternate realities, their potential existence, how they may interact with our own universe, and the mysteries they hold, you don't need to concentrate or remember anything. Simply listen, breathe, and let the possibilities of infinite realities unfold in your mind as softly and endlessly as the night sky. So settle in, get comfortable, and let the quiet wonder of parallel universes guide you into a peaceful, restful state. Fact first, the origins of parallel universe theory. The concept of parallel universes, or the multiverse theory, finds its roots in the groundbreaking work of quantum mechanics and cosmology. The notion of multiple realities beyond our own is not entirely new, but it was brought into serious scientific discussion in the 20th century. The many worlds interpretation, MWI, proposed by physicist Hugh Everett III in 1957, was one of the earliest scientific attempts to explore parallel universes. Everett's interpretation posited that, rather than a single, definite outcome from a quantum event, multiple outcomes can coexist simultaneously, each corresponding to a different universe. In quantum mechanics, when particles like electrons are measured, their wave function collapses to a single outcome. However, Everett suggested that instead of collapsing, the wave function continues to exist in all possible states, effectively creating multiple worlds. This groundbreaking interpretation was initially met with skepticism, as it challenges conventional understanding, but it provided a new way to solve the paradoxes of quantum mechanics, such as Schrödinger's cat. The idea of parallel universes gained more popularity as modern physics evolved, with new developments like quantum field theory and string theory reinforcing the possibility that our universe might not be the only one in existence. Today, parallel universe theory serves as a cornerstone in discussions about the nature of reality, offering a possible explanation for many of the unsolved mysteries in physics. Yet, the theory remains controversial, and empirical evidence to fully support it has yet to be discovered. Despite this, the idea of parallel universes continues to intrigue physicists and remains a source of inspiration for scientists and science fiction enthusiasts alike. Fact second, the many worlds interpretation, MWI. The many worlds interpretation, MWI, of quantum mechanics, introduced by Hugh Everett III in the 1950s, is one of the most significant ideas to support the concept of parallel universes. The MWI fundamentally alters the way we perceive quantum events. Traditionally, quantum mechanics holds that when a particle is measured, its wave function collapses to a single state. In contrast, Everett's MWI argues that rather than the wave function collapsing, all possible outcomes of a quantum measurement coexist, each in its own separate universe. This means that every possible event, no matter how small or seemingly insignificant, results in the creation of a new parallel universe. In the MWI, the universe is constantly splitting into a multitude of different realities. For instance, if you flip a coin, instead of the outcome being decided in one universe, two universes are created, one where the coin lands heads and another where it lands tails. These universes continue to evolve separately from each other, each with its own version of events, which can go on to develop into vastly different realities. This interpretation is in direct contrast to the Copenhagen interpretation, which holds that the wave function collapses upon measurement, resulting in a single outcome. MWI also offers a solution to the infamous Schrödinger's cat thought experiment, where a cat inside a box can be simultaneously alive and dead. In MWI, the universe splits, and the cat is both alive in one universe and dead in another. While MWI has been praised for providing a coherent explanation for quantum events, it remains controversial due to its unobservable nature. Critics argue that it raises questions about the true meaning of reality, as it suggests the existence of an infinite number of universes, each with its own version of history. Fact third, the string theory and extra dimensions. One of the most influential theories in modern physics, string theory, proposes that the fundamental particles of the universe are not point-like objects, but instead tiny, vibrating strings. These strings vibrate at different frequencies, and their vibrations give rise to the particles and forces that make up the universe. String theory also posits that there are more than the familiar three spatial dimensions and one time dimension we experience in everyday life. In fact, string theory suggests there could be as many as 10 or 11 dimensions in total. These extra dimensions, which are compactified and hidden from our perception, could hold the key to understanding parallel universes. According to string theory, the different vibrations of these strings could lead to the creation of different universes, each with its own set of physical laws. This is where the idea of the multiverse comes into play. If there are indeed multiple dimensions, then each dimension could represent a different universe, potentially with very different physical constants and properties. Furthermore, string theory offers the possibility of brains, multi-dimensional objects that could exist in higher dimensional space. Our universe, according to some versions of string theory, might be a three-dimensional brain floating in a higher dimensional space, with other brains representing parallel universes. These brains could occasionally collide, leading to the creation of new universes, or triggering cosmological events like the Big Bang. The concept of parallel universes in string theory opens up the possibility of an almost infinite number of realities, each with its own unique structure and laws of physics. Despite its promise, string theory remains unproven, as it is difficult to test experimentally due to the lack of direct evidence for higher dimensions or brains. However, it continues to be a powerful tool in theoretical physics, providing insights into the nature of space, time, and parallel universes. Fact 4. The cosmic inflation theory and the multiverse. The theory of cosmic inflation, introduced by physicist Alan Guth in the early 1980s, revolutionized our understanding of the universe's early moments. According to cosmic inflation, the universe expanded exponentially in a fraction of a second after the Big Bang, growing from subatomic scales to a vast, almost incomprehensible size. This rapid expansion would have led to the formation of pocket or bubble universes, each with its own set of properties and physical laws. these bubbles could continue to evolve independently of one another, forming a vast and ever-expanding multiverse. The idea of eternal inflation suggests that inflation did not stop after the formation of our universe, but continues indefinitely, with new bubbles constantly emerging. Each of these bubbles represents a new universe, with its own version of space and time. In some of these universes, the physical constants might be fine-tuned for the existence of life, while in others, the conditions may be completely inhospitable. This suggests that the multiverse could contain a nearly infinite number of universes, some similar to ours, and others vastly different. Cosmic inflation provides a compelling framework for understanding the uniformity and structure of the universe. It explains why the universe appears to be flat, homogeneous, and isotropic, with regions that are far apart, yet exhibit similar properties. Eternal inflation could also help explain the fine-tuning problem, the observation that the physical constants of our universe appear to be perfectly suited for life. In a multiverse, it's possible that we simply exist in one of the many universes where the conditions happen to support life, while other universes may not. Though the idea of eternal inflation and the multiverse is still speculative, it has generated significant interest among cosmologists and physicists, and future observational evidence may one day provide a deeper understanding of the multiverse's existence. Fact 5. The mathematical framework of parallel universes. The concept of parallel universes is not only a philosophical idea, but also a mathematical one, grounded in the principles of quantum mechanics and probability theory. The Schrödinger equation, which governs the behavior of quantum systems, plays a central role in the development of parallel universe theories. In traditional quantum mechanics, when a particle is measured, its wave function collapses to a single outcome. However, in the context of parallel universes, the wave function does not collapse. Instead, all possible outcomes of a quantum event exist in parallel, each in a separate universe. Mathematically, the many worlds interpretation, MWI, of quantum mechanics provides a framework for understanding the branching of universes. The wave function is treated as a superposition of all possible states, and when a quantum measurement occurs, the universe splits into distinct branches, each corresponding to a different outcome. These branches then evolve independently, creating multiple parallel universes that coexist in a higher dimensional space. The mathematics of quantum mechanics suggests that the universe is fundamentally probabilistic. Every quantum event, no matter how small, has a certain probability of leading to one outcome or another. In the context of parallel universes, each of these possibilities is realized in a separate universe, meaning that every potential outcome of every event has a corresponding universe in which it occurs. This raises profound questions about the nature of reality, as it implies that there are an infinite number of versions of ourselves, each living a different life based on the choices we make. Though the idea of parallel universes is deeply rooted in mathematics, it is difficult to test empirically. The mathematical models can provide intriguing insights into the nature of reality, but without direct evidence, the theory remains speculative. Nonetheless, the mathematical framework of parallel universes continues to be a powerful tool in theoretical physics and cosmology. Fact 6. The anthropic principle and multiverses. The anthropic principle is a philosophical argument used to explain why the universe seems so finely tuned to support life, It suggests that the physical constants and laws of the universe are not random, but are specifically suited for the existence of life as we know it. One of the challenges of the anthropic principle is explaining why the universe's physical parameters, such as the strength of gravity and the charge of the electron, are so precisely balanced. If these constants were even slightly different, life would not be possible. The anthropic principle has led some physicists to propose that our universe is just one of many in a larger multiverse. In a multiverse, each universe could have different physical constants, and only those with the right conditions for life would give rise to observers like us. This is known as the weak anthropic principle, which argues that the universe we observe is not unique, but is one of many universes, each with its own set of conditions. The fine-tuning of our universe is simply a result of selection bias. Only those universes with the right conditions for life are able to support observers who can question their own existence. The anthropic principle raises significant philosophical and scientific questions about the nature of reality. Some critics argue that it is a tautological explanation, essentially stating that the universe must be the way it is because we are here to observe it. Others see it as a profound insight into the nature of existence, suggesting that the multiverse could provide a natural explanation for the apparent fine-tuning of our universe. Regardless, the anthropic principle continues to spark debate and is central to many discussions about the multiverse. Fact 7. The simulation hypothesis and parallel universes. The simulation hypothesis, popularized by philosopher Nick Bostrom, proposes that our reality might not be the base reality, but instead a sophisticated simulation created by an advanced civilization. According to this hypothesis, as technology advances, future civilizations may create highly realistic simulations of their ancestors or entirely new worlds. These simulations would be indistinguishable from real life, and those within the simulation would be unaware that they are living in a digital environment. In the context of parallel universes, the simulation hypothesis suggests that our universe could be just one of many simulated realities. Each of these realities could be running on different computers, each with its own set of rules, parameters, and inhabitants. If our reality is indeed a simulation, then it is possible that the multiverse consists of an infinite number of simulations, each with its own version of history and different outcomes. This would mean that parallel universes are not necessarily separate physical realities, but could instead be different programs or simulations. The idea of the simulation hypothesis raises intriguing questions about the nature of existence and the role of consciousness. If we are living in a simulation, what does that say about the true nature of reality? Are the parallel universes simply different versions of a simulation, or do they represent entirely separate digital constructs? While the simulation hypothesis remains speculative, it provides a new way to think about the nature of reality and the possibility of parallel universes. Fact 8. The holographic principle and parallel realities. The holographic principle is a concept that suggests the three-dimensional universe we experience could be a projection from a two-dimensional surface. Proposed by physicists Gerard 't Hooft and Leonard Susskind, the holographic principle implies that all of the information in our universe, everything from particles to galaxies, could be encoded on a distant boundary, like the surface of a black hole. According to this idea, our three-dimensional reality is merely a holographic projection of this two-dimensional information. This principle offers a fascinating way to think about parallel universes. If our universe is a projection from a two-dimensional surface, then it is possible that other universes could exist as different projections from the same surface. Each of these universes would be a different holographic reality with its own set of physical laws, constants, and structures. These universes could interact with each other in ways that we don't yet understand, potentially leading to collisions or exchanges of information between different holographic realities. The holographic principle provides a unique perspective on the nature of space, time, and reality. It suggests that what we perceive as reality may not be the full picture, and that there could be multiple parallel projections of information that coexist alongside our own. If this principle holds true, it could offer a new way to understand the concept of parallel universes and the possible connections between them. Fact 9. Evidence from cosmic microwave background radiation. One of the most intriguing potential pieces of evidence for parallel universes comes from the study of cosmic microwave background radiation, CMB. The CMB is the afterglow of the Big Bang and is often considered one of the most important pieces of observational evidence about the early universe. As scientists study the CMB, they have noticed certain anomalies and patterns that could be consistent with the existence of other universes. Some physicists speculate that these anomalies might be the result of interactions between our universe and other parallel universes. For example, cold spots or unusual fluctuations in the CMB have been observed, and some researchers believe that these might be signs of collisions between our universe and neighboring parallel universes. If two universes were to collide, their respective physical fields could influence the CMB, leaving behind detectable imprints. Although this remains speculative, the study of these anomalies continues to be an area of active research. If further analysis reveals patterns that are difficult to explain through conventional physics, it could provide strong evidence for the existence of parallel universes. While the evidence for parallel universes from the CMB is still inconclusive, these findings provide an intriguing direction for future investigations. As our technology and understanding of the cosmos improve, we may uncover more signs that point to the existence of parallel worlds. Fact 10. The fine-tuning problem and the multiverse. The fine-tuning problem refers to the observation that the physical constants of our universe, such as the strength of gravity and the mass of elementary particles, appear to be precisely set to allow for the existence of life. If any of these constants were even slightly different, life as we know it would not be possible. This has led scientists to ask, why is the universe so perfectly fine-tuned for life? One possible solution to this puzzle is the idea of the multiverse. In a multiverse scenario, there would be an almost infinite number of universes, each with different physical constants. Some of these universes might have conditions that are not conducive to life, but others might have constants that are perfectly suited to the formation of life. This suggests that the apparent fine-tuning of our universe is not a coincidence, but rather a result of living in a universe that just happens to have the right conditions. This multiverse explanation offers a natural resolution to the fine-tuning problem. Instead of assuming that our universe is special or unique, it suggests that we simply live in one of the many universes where the conditions happen to support life. This idea challenges our understanding of the universe and suggests that we may be part of a much larger, more complex cosmic structure than we previously imagined. Fact 11. The landscape multiverse and string theory. In string theory, the idea of a landscape multiverse arises from the possibility of different solutions to the equations governing the behavior of strings. String theory suggests that there are a multitude of ways in which the extra dimensions of the universe can be compactified or curled up. Each configuration of compactified dimensions can lead to a different set of physical laws and constants, giving rise to a vast landscape of potential universes. The number of possible universes that can arise from these different compactifications is staggering, with estimates ranging from 10⁵ possible configurations. This landscape of possible universes could mean that our universe is just one in an incredibly vast collection, each with its own version of physical laws. For example, one universe could have strong gravity, while another might have weaker gravity, or completely different fundamental forces. Some universes might even have different numbers of dimensions, radically altering their structure and potential for life. The landscape multiverse is an intriguing concept because it implies that the specific conditions that allow for the existence of life are not special or unique to our universe. Instead, they could be the result of random selection from the vast array of possible universes, a consequence of living in one of many universes within a larger multiverse. While the landscape multiverse remains a theoretical idea and is difficult to test directly, it has become a central feature of many cosmological models based on string theory. It suggests that the universe we observe is just one of many, each shaped by different mathematical configurations of the extra dimensions. Fact 12. The role of black holes in parallel universes. Black holes, one of the most mysterious and enigmatic phenomena in the universe, may play a crucial role in the formation of parallel universes. According to certain theories, when a black hole forms, it creates a singularity at its core, a point of infinite density where the laws of physics as we know them break down. Some physicists believe that the intense gravitational forces around black holes could give rise to new, separate universes. This idea is rooted in the black hole cosmology theory, which suggests that the interior of a black hole could be the gateway to a new, independent universe. When matter is sucked into a black hole, it may be compressed to such an extreme that it forms the conditions for the birth of a new universe. In this model, each black hole could serve as a seed for a new universe, potentially with different physical properties and constants. One of the most fascinating aspects of this theory is the idea that the event horizon of a black hole, the boundary beyond which nothing can escape, might be a portal to another universe. When matter crosses the event horizon, it might not simply disappear, but instead form a new, distinct universe. In this way, black holes could be connected to the multiverse, serving as birthplaces for parallel realities. This hypothesis is still speculative, and no direct evidence for it exists. However, the mathematical framework surrounding black holes and quantum mechanics suggests that black holes may indeed be more than just cosmic vacuum cleaners. They could be the birthplaces of entire new universes, each with their own unique properties. Fact 13. The many worlds, quantum computer, and parallel universes. The idea of parallel universes has found applications in the development of quantum computing. Quantum computers operate on the principles of quantum mechanics, where bits are replaced with qubits, which can exist in multiple states simultaneously. This unique property of qubits allows quantum computers to perform complex calculations at speeds far beyond what classical computers are capable of. The connection between quantum computing and parallel universes lies in the many worlds interpretation of quantum mechanics. As quantum computers process information, each potential state of a qubit may correspond to a different branch of the universe. When a quantum computer performs a calculation, it essentially splits the universe into multiple branches, with each branch representing a different outcome of the computation. This means that parallel universes could be created every time a quantum computer runs a calculation, with each parallel universe containing a different result. While this is still a theoretical idea, the implications of quantum computing for parallel universes are profound. If quantum computers can create new branches of reality with every calculation, they could potentially be interacting with or creating parallel universes in a tangible way. Although we are still far from fully understanding the relationship between quantum computing and parallel universes, these insights might eventually lead to new ways of exploring the multiverse. Fact 14. The role of parallel universes in time travel. Time travel has long been a popular concept in science fiction, but recent theories in physics suggest that parallel universes might play a role in making time travel possible. According to the many worlds interpretation of quantum mechanics, every decision or event creates a branch in the universe, forming a new reality with a different outcome. This branching could allow for time travel, but not in the traditional sense. Rather than traveling backward or forward within a single timeline, time travel in the context of parallel universes might involve moving between different branches of reality. For example, if you could access another universe that diverged from ours at a certain point in history, it would appear as though you were traveling through time, even though you are actually shifting between alternate realities. One of the key ideas supporting this concept is the idea of closed, time-like curves, CTCs, which are theoretical paths through space-time that loop back on themselves. If these paths exist in the fabric of space-time, they could allow for time loops and time travel within a single universe. However, if the multiverse exists, these loops could connect different timelines or universes, allowing for travel across both time and space. While time travel to the past remains highly speculative and faces numerous paradoxes, such as the famous grandfather paradox, the concept of using parallel universes to navigate time offers an intriguing solution. If time travel were possible through the multiverse, the paradoxes that arise from changing the past might be avoided, as the traveler would be moving into a different version of reality rather than altering their original timeline. Fact 15. The quantum multiverse and infinite possibilities. One of the most fascinating aspects of the multiverse theory is the idea of the quantum multiverse. According to this theory, every quantum event creates not just a single outcome, but an infinite number of possible outcomes, each corresponding to a different universe. This means that every time a decision is made, no matter how trivial, an entirely new universe is created with a different version of reality. For instance, imagine a person making a decision, like choosing to go left or right at an intersection. In the quantum multiverse, there would be an infinite number of universes, each representing one of the possible choices. In one universe, the person goes left, and in another, they go right. These universes would diverge and evolve separately, each containing a different version of the individual's life and experiences. The quantum multiverse suggests that the possibilities for the future are endless, and every event that can happen does happen in some parallel universe. In a sense, the multiverse provides a model for infinite realities, each one unique and shaped by the infinite possibilities of quantum events. This idea challenges our conventional understanding of reality and suggests that every possibility, no matter how improbable, is realized in some universe. Although this theory is based on the many worlds interpretation of quantum mechanics, it raises profound questions about the nature of free will, fate, and determinism. If every choice we make creates a new universe, then it would seem that our actions are both meaningful and meaningless at the same time. Meaningful in the context of our own reality, but insignificant when considering the infinite number of other universes where other choices were made. Fact 16. The role of gravity in the formation of parallel universes. In the context of the multiverse, gravity plays an essential role in shaping the structure and formation of parallel universes. According to theories like eternal inflation and string theory, the formation of new universes is often tied to the dynamics of gravity, particularly in the early moments of the universe's existence. During the rapid expansion following the Big Bang, gravity would have played a crucial role in determining the shape and behavior of the universe. In some models of the multiverse, gravity is responsible for the creation of bubble universes, regions of space-time where inflation slows down, allowing for the formation of distinct, isolated universes. These bubble universes could have different gravitational constants, which would in turn affect the development of stars, galaxies, and even the possibility of life. The strength of gravity also influences the possibility of new universes forming within black holes. As mentioned earlier, black holes could potentially serve as portals to new universes, and the gravity within a black hole could provide the necessary conditions for the birth of a new universe. This suggests that gravity might not only govern the behavior of our own universe, but could also be a key player in the creation and structure of parallel universes. In essence, gravity's influence on space-time and its ability to shape the evolution of the universe makes it an essential factor in the formation of parallel worlds. Without gravity, the conditions necessary for the creation of new universes may not exist, and the multiverse may remain a theoretical concept rather than a physical reality. Fact 17. The concept of bubble universes in cosmology. In the context of the multiverse theory, bubble universes are one of the most intriguing ideas proposed by cosmologists. According to the theory of eternal inflation, the rapid expansion of the universe during the first moments of the Big Bang did not cease everywhere at once. Instead, some regions of space-time continued to inflate at an accelerated rate, creating separate bubbles within the larger fabric of the universe. Each bubble could potentially develop into a distinct universe with its own set of physical laws and properties. These bubble universes would be isolated from one another, with no interaction possible between them. The bubbles could be separated by vast distances, potentially beyond the reach of any future technological advancements. Each bubble could contain different constants of nature, such as the strength of gravity or the charge of the electron, leading to universes with radically different structures and properties. Some versions of the bubble universe concept suggest that each bubble could form its own distinct space-time continuum, with its own version of space and time. This would imply that there are parallel universes where the very nature of reality is different from our own. In some universes, life might not exist, or the laws of physics could be fundamentally different, making them unrecognizable to us. The concept of bubble universes provides a potential framework for understanding how a multiverse could emerge and how multiple universes could exist independently of each other. Fact 18. Quantum, entanglement, and parallel realities. Quantum entanglement is a phenomenon in quantum mechanics where two or more particles become correlated in such a way that their properties are instantaneously linked, regardless of the distance separating them. When one particle's state is measured, the state of the other particles is immediately determined, even if they are light years apart. This mysterious connection between particles has led to speculations about its relationship with parallel universes. In the context of parallel universes, quantum entanglement could provide a mechanism for particles to communicate across different branches of reality. Some physicists suggest that entangled particles might actually exist in multiple universes simultaneously, their states shared across different timelines or realities. This means that the outcome of quantum measurements, while seemingly random, could be influenced by parallel universes, each contributing its own version of the measurement. Entanglement could therefore be a bridge between parallel realities, suggesting that what we perceive as separate universes might be more connected than we realize. If quantum entanglement allows particles to influence each other across vast distances, it raises the possibility that universes too might be able to influence each other in ways that are not yet fully understood. Fact 19. The quantum multiverse and infinite possibilities. The quantum multiverse theory posits that each quantum event gives rise to a new parallel universe. Every time a quantum decision is made, such as a particle's location or spin, it creates an alternative outcome, resulting in the formation of a new branch of the universe. This implies that there is an infinite number of parallel universes, each one representing a different possibility of a quantum event. If true, this means that every decision we make, no matter how insignificant, creates a new universe, and in each of these universes, a different version of ourselves exists. The concept of infinite parallel universes challenges our traditional understanding of time and reality. It suggests that every choice we make creates an alternate timeline, leading to a never-ending series of possibilities. In this model, there would be an infinite number of versions of ourselves, each living out different lives based on the choices we make. The quantum multiverse provides a way to think about free will and determinism, suggesting that every possible outcome exists, but each is realized in a different universe. This theory has profound philosophical implications, as it raises questions about the nature of consciousness and identity. If there are infinite versions of ourselves in different universes, what does that mean for the uniqueness of our experiences? Are we truly free to make choices, or are we simply navigating through a multiverse of infinite possibilities? Fact 20. The simulation, hypothesis, and parallel universes. The simulation. Hypothesis, proposed by philosopher Nick Bostrom, suggests that our reality might not be the base reality, but instead a highly advanced simulation created by an advanced civilization. According to this hypothesis, as technology advances, future civilizations could develop the capability to simulate entire universes. These simulations would be so realistic that their inhabitants, including us, would be unaware that they are living in a digital world. In the context of parallel universes, the simulation hypothesis offers a unique perspective. If our universe is a simulation, it could be one of many running simultaneously on a powerful computer. Each of these simulations could represent a different parallel universe, with distinct laws of physics, different versions of history, and entirely separate realities. The multiverse, in this case, could be a collection of these simulated universes, each created by an advanced civilization for exploration, study, or entertainment. The idea of simulations raises intriguing questions about the nature of reality and the potential for parallel universes. If we are living in a simulation, what does that say about the true nature of existence? Could there be an infinite number of simulated universes, each one governed by different rules and inhabited by different versions of ourselves? The simulation hypothesis adds an entirely new layer to the concept of the multiverse, suggesting that the parallel universes we contemplate may not be physical entities at all, but digital constructs running on an advanced computer. Fact 21. The holographic principle and parallel universes. The holographic principle is a revolutionary idea in theoretical physics that suggests our three-dimensional universe might be a projection of information encoded on a two-dimensional surface. This principle was first proposed by Gerard 't Hooft and Leonard Susskind, and it has since gained attention as a potential explanation for the nature of space-time and gravity. According to this theory, the entire universe could be seen as a hologram, a three-dimensional projection of information contained on a distant two-dimensional boundary, much like the way a hologram projects a three-dimensional image from a flat surface. This idea has profound implications for parallel universes. If our universe is a hologram, then it is possible that other universes could exist as separate projections from the same two-dimensional boundary. These other universes might have entirely different laws of physics, or even different numbers of dimensions. In this framework, the multiverse could be made up of an infinite number of parallel universes, each with its own projection of information and unique physical properties. The holographic principle has been particularly influential in the study of black holes and the nature of quantum gravity. According to the principle, information about everything that enters a black hole is not lost, but rather encoded on the surface of the black hole, and this information could be projected into another universe. This idea could provide a new way of thinking about the formation and interaction of parallel universes, suggesting that they may be connected through higher dimensional projections of information. Although the holographic principle is still speculative, it opens up exciting possibilities for understanding the nature of space, time, and parallel universes. Fact 22. The role of entropy in the multiverse. Entropy is a fundamental concept in thermodynamics that measures the degree of disorder or randomness in a system. In the context of the multiverse, entropy plays an essential role in determining the fate of parallel universes. According to the second law of thermodynamics, entropy tends to increase over time, meaning that the universe naturally moves toward greater disorder and randomness. In a multiverse, each universe could have its own unique entropy value, with some universes experiencing higher levels of disorder and others remaining relatively stable. This variation in entropy across different universes could provide a framework for understanding why our universe is so finely tuned for life. Some physicists speculate that our universe exists in a low entropy state, which allows for the formation of complex structures like stars, galaxies, and life. In contrast, other universes may have higher entropy, making them inhospitable to life. The idea of entropy in a multiverse also ties into the heat-death hypothesis, which suggests that the universe will eventually reach a state of maximum entropy, where all processes cease and no usable energy remains. However, in a multiverse scenario, different universes could experience their own heat death at different times, meaning that some universes could continue to exist in a state of order and stability, while others may face inevitable decay. This raises interesting questions about the long-term fate of parallel universes. Could some universes escape the inevitable increase in entropy by following different physical laws or by having a different amount of initial entropy? If parallel universes exist, they may follow distinct paths toward order or chaos, providing a broader understanding of entropy's role in the cosmos. Fact 23. The quantum Zeno effect and parallel universes. The quantum Zeno effect is a phenomenon in quantum mechanics where the act of measuring a system repeatedly can prevent it from evolving. Essentially, if you observe a quantum system frequently enough, you freeze its state, and it doesn't progress to other possible states. This strange effect has intrigued physicists and has been linked to the concept of parallel universes. In the context of parallel universes, the quantum Zeno effect might offer a way for different versions of reality to coexist without interacting with each other. When we observe a quantum system, we force it into one of its possible states, essentially locking it into a particular reality. If the universe is constantly being measured, every observation could result in the splitting of the universe into multiple parallel realities, each one representing a different possible outcome of the measurement. This effect could be responsible for the way that different outcomes are realized in a multiverse. When a quantum event occurs, such as the measurement of a particle's position, the universe might split into multiple branches, each corresponding to a different outcome. The quantum Zeno effect could prevent any one branch from disappearing, allowing the different realities to continue to exist and evolve independently of one another. While the quantum Zeno effect has not been directly connected to the formation of parallel universes, it provides a fascinating way to think about how measurements and observations could create distinct, branching realities. This effect underscores the role of observation in quantum mechanics and hints at how our actions could shape the multiverse. Fact 24. The multiverse and the nature of free will. The theory of parallel universes has significant implications for the concept of free will. In a multiverse scenario, every decision we make could create a new universe with a different version of ourselves living out each possible outcome. This suggests that every choice we make may not only affect our own reality, but also create an infinite number of parallel universes, each one representing a different choice. For example, if you decide to take a particular job, one universe would exist where you took that job, and another universe would exist where you chose a different path. In this way, the multiverse may provide a mechanism for exploring the consequences of all possible decisions. Some versions of you might live entirely different lives based on the choices they made, while others may follow similar paths. This raises questions about the nature of free will. If every choice we make results in the creation of a new universe, does that mean that our actions are predetermined, with each possible outcome already existing in parallel realities? Alternatively, it could suggest that we have true free will, as each decision we make generates a new universe with different consequences. The multiverse theory challenges our understanding of fate and free will, suggesting that our choices may not be as deterministic as we once believed. The idea of parallel universes provides a novel perspective on the age-old debate between free will and determinism. In a multiverse, our actions might create an infinite number of possible realities, each one influenced by our decisions. Fact 25. The cosmic web and parallel universes. The cosmic web is the large-scale structure of the universe, composed of galaxies, dark matter, and vast voids that form a network-like pattern. This structure is often compared to a web or a honeycomb, with dense regions of galaxies interconnected by vast voids. Some theories suggest that the cosmic web could be a manifestation of a much larger multiverse, with each cell or bubble in the web representing a different parallel universe. The cosmic web could provide a way for different universes to be connected in a larger, multidimensional structure. Each bubble in the cosmic web could be a separate universe, with its own set of physical laws, constants, and properties. These bubbles could be interconnected through higher dimensional space, creating a vast network of parallel universes. The idea of the cosmic web as a representation of the multiverse suggests that the universe we observe is just one node in an enormous structure of realities. If this is the case, our universe may not be isolated, but part of a much larger cosmic system. This interconnectedness of universes could provide insights into the fundamental nature of reality, suggesting that parallel universes are not separate entities, but part of a larger, unified structure. While this idea is still speculative, it has inspired cosmologists to explore the large-scale structure of the universe in new ways. The cosmic web could hold clues to the existence of parallel universes, and future research in this area may offer new ways of understanding the multiverse. Fact 26. The multiverse and the fine-tuning of life. One of the most perplexing questions in cosmology is the fine-tuning problem. The observation that the physical constants of the universe are precisely calibrated to support life. If the strength of gravity or the charge of the electron were even slightly different, life as we know it would not be possible. This precise balance of constants has led some scientists to propose that the universe is not uniquely fine-tuned for life, but that we simply exist in one of many universes, each with different physical properties. In a multiverse scenario, there could be countless universes, each with a different set of physical laws and constants. Some of these universes might have the right conditions for life, while others might be inhospitable to life as we understand it. This provides a potential solution to the fine-tuning problem. The reason our universe is so perfectly suited for life is not because it is special, but because we happen to live in one of the many universes that has the right conditions. This idea of a multiverse of fine-tuned universes helps explain why we observe a universe that seems so finely tuned for life. If there are countless other universes with different properties, the fact that we live in one that supports life is simply a matter of chance. The multiverse provides a natural explanation for the apparent coincidence of life-friendly conditions in our universe. While this theory is still speculative, it offers an elegant solution to one of the most profound mysteries of modern science: the fine-tuning of the universe for life. Fact 27. The idea of ghost universes and parallel realities. The concept of ghost universes arises from the idea that some parallel universes might be ghostly or invisible to us. These universes would exist in a way that is fundamentally different from our own, with physical laws or properties that prevent them from interacting with or being detected by our universe. The idea of ghost universes suggests that there could be realms that are completely separate from ours, with entirely different types of matter, energy, or even dimensions of time. One possibility is that these ghost universes could be located in higher dimensions, where they are close to our universe, but exist in a separate dimension that is inaccessible to us. If these universes are in a higher dimensional space, they might not be detectable through any means in our three-dimensional world. Alternatively, these universes could have physical laws that prevent interaction with our universe, creating a kind of bubble around them that keeps them isolated. While the idea of ghost universes is highly speculative, it offers a way to think about parallel universes that might not be directly observable. These universes could exist alongside us, separated by dimensions or laws of physics that we cannot yet comprehend. Fact 28. The role of dark matter in parallel universes. Dark matter is one of the most mysterious substances in the universe. It does not emit light or energy, making it invisible to telescopes, yet its presence is inferred from its gravitational effects on visible matter. Some scientists believe that dark matter could play a key role in the formation and structure of parallel universes. According to some theories, dark matter could be a bridge between our universe and other universes, allowing for interaction or even travel between parallel realities. One hypothesis suggests that dark matter could exist in other universes in forms that are not detectable by our instruments. These dark matter particles might interact with our universe in subtle ways, potentially causing the gravitational anomalies observed in galaxy rotation curves. If dark matter is a manifestation of matter from other universes, it could provide a way for parallel universes to influence each other without directly interacting. The idea that dark matter could connect different universes opens up exciting possibilities for the multiverse. If dark matter is linked to parallel universes, it might provide clues about the structure and interaction of the multiverse. This could lead to a deeper understanding of both dark matter and the nature of parallel realities. Fact 29. The role of consciousness in parallel universes. The question of consciousness and its relationship to parallel universes is one of the most profound and mysterious aspects of the multiverse theory. Some theorists propose that consciousness itself may be a key player in the creation of parallel universes. According to the many worlds interpretation of quantum mechanics, every possible outcome of a quantum event leads to the creation of a new universe. If consciousness is involved in the observation or measurement of these events, it might choose which reality to experience, thus creating new parallel universes. This idea suggests that consciousness is not merely a passive observer of reality, but an active participant in the creation of the multiverse. Every decision or observation could create a branching universe, with consciousness acting as the catalyst for the splitting of realities. This raises fascinating questions about the nature of reality. If consciousness is responsible for the creation of parallel universes, then each of us could be living in a multiverse of our own making, with each choice we make generating a new version of reality. While this idea is speculative and controversial, it touches on some of the deepest questions in both philosophy and quantum mechanics. The role of consciousness in the multiverse could provide a way to understand how parallel universes emerge and how they are connected to our perception of reality. Fact 30. The role of quantum decoherence in parallel universes. Quantum decoherence refers to the process by which a quantum system transitions from a superposition of states to a single, observable state. In simple terms, decoherence explains how quantum systems choose one outcome when they are measured, thus collapsing the wave function. However, in the context of the many worlds interpretation, MWI, of quantum mechanics, decoherence is the mechanism that causes the universe to split into multiple realities, with each possible outcome of a quantum event occurring in a separate branch of the multiverse. When a quantum system interacts with its environment, such as when an observer measures it, the coherence between the different possible states of the system is lost, causing the system to behave as though it has collapsed into a single state. According to MWI, however, all possible outcomes still exist in separate universes. The idea is that decoherence allows for the separation of these outcomes, making them distinct, non-interacting realities. As a result, the act of observing a quantum system doesn't collapse the wave function into a single outcome, but rather splits the universe into multiple branches, each corresponding to a different result. In this sense, decoherence provides a natural explanation for the creation of parallel universes. It suggests that every time a quantum event occurs, whether it's the spin of an electron or the measurement of a particle's position, each possible outcome creates a new universe. This concept challenges the traditional view of quantum mechanics, where the wave function collapse is seen as the end of a quantum event, instead proposing a universe that constantly splits into many, each containing a different realization of reality. Fact 31. The multiverse and the concept of quantum foam. In theoretical physics, quantum foam is the concept that at extremely small scales, space-time behaves in a highly turbulent, frothy manner. According to John Wheeler, the man who coined the term, quantum foam exists at the Planck scale, the smallest possible scale of space-time, where quantum fluctuations dominate. The idea is that space-time is not smooth, but rather fluctuates, with tiny fluctuations occurring everywhere, creating bubbles of space and time. These quantum fluctuations could be the seeds from which parallel universes arise. If the quantum foam represents a dynamic and ever-changing landscape of space-time, it is plausible that these fluctuations could give rise to new regions of space-time that form independent universes. As a result, the multiverse could be an intricate, bubbling structure of universes, continuously being born and evolving from the quantum foam. These universes would be separate from one another, each experiencing its own version of space and time. Quantum foam provides a potential framework for the multiverse, suggesting that parallel universes are not isolated, but are constantly emerging from the turbulent fabric of space-time. The existence of these quantum fluctuations supports the idea that our universe could be just one of many, with others being created at the smallest scales of reality. Fact 32. The role of the quantum vacuum in parallel universes. The quantum vacuum is the lowest possible energy state in quantum field theory, and it is not empty, but filled with fluctuating fields and particles. These fluctuations are responsible for the creation of particles out of nothing, a phenomenon known as quantum fluctuations. Some theorists propose that the quantum vacuum could play a role in the creation of parallel universes. In models of the multiverse, the quantum vacuum could serve as the seed for the formation of new universes. These universes could emerge from regions of space where quantum fluctuations cause the creation of bubbles of space-time, each with different physical properties. The process of eternal inflation, where the universe expands rapidly in its early stages, could be driven by these fluctuations in the quantum vacuum. In this framework, each fluctuation in the quantum vacuum could create a new universe, leading to an ever-expanding multiverse. The quantum vacuum could also provide a mechanism for the interaction of parallel universes. If the vacuum fluctuates across multiple universes, it might allow for the transfer of information or energy between them. This could create subtle connections between different universes, even if they remain largely independent of each other. While the quantum vacuum is a well-established concept in quantum field theory, its potential role in the formation of parallel universes remains speculative, but it provides an intriguing foundation for multiverse theories. Fact 33. The many worlds. Interpretation and consciousness. The relationship between consciousness and the many worlds. Interpretation, MWI, of quantum mechanics is a deeply debated and speculative topic. According to MWI, every quantum event results in the splitting of the universe, creating multiple parallel realities, each corresponding to a different outcome. This raises the question, how does consciousness interact with this branching process? One possibility is that consciousness follows the same branching pattern, with each version of the observer existing in a different parallel universe. When a quantum measurement occurs, the observer's consciousness would split along with the universe, experiencing only one of the possible outcomes. For example, if you were to make a decision, the universe would split into two versions, one in which you choose option A, and another where you choose option B. And your consciousness would experience only one of these outcomes, while the other version of you experiences the other universe. This idea implies that consciousness is not a single, unified experience, but instead exists in multiple forms across different realities. This raises profound questions about personal identity and the nature of free will. If consciousness can split across universes, it suggests that we may be living in a multiverse of subjective experiences, with each version of ourselves experiencing a different reality. While this idea remains speculative and untestable, it offers a unique perspective on the role of consciousness in the multiverse. Fact 34. The quantum multiverse and the nature of time. The concept of time in parallel universes is one of the most challenging aspects of the multiverse theory. In classical physics, time is viewed as a continuous, linear progression. However, in quantum mechanics, time behaves differently. And in the context of the multiverse, it may not be the same across all realities. According to some versions of the many worlds interpretation, each parallel universe exists in its own timeline, with its own version of past, present, and future. These universes are not necessarily synchronized with one another, and time could flow differently in each one. For instance, in one universe, time may progress more slowly due to differences in the constants of nature, while in another universe, time might move much faster. This divergence of time across parallel universes raises questions about the nature of temporal relationships between these realities. If each universe experiences time in its own way, could there be universes where time doesn't exist at all? Could parallel universes be timeless, existing outside the conventional flow of time that we experience in our universe? Additionally, the possibility of time travel between parallel universes is a topic of speculation. If time is not uniform across all realities, it may be possible to travel between universes with different temporal properties. This would introduce a new level of complexity to our understanding of time, suggesting that time itself might be an emergent property that varies between different realities in the multiverse. Fact 35. The simulation hypothesis and parallel realities. The simulation hypothesis, proposed by philosopher Nick Bostrom, suggests that our reality is a highly sophisticated simulation created by a superintelligent civilization. According to this hypothesis, as technology advances, future civilizations may create highly detailed simulations of their ancestors or entirely new worlds. These simulations would be indistinguishable from real life, and the inhabitants of these simulations would be unaware of their artificial nature. In the context of parallel universes, the simulation hypothesis raises the possibility that each simulation could represent a separate parallel universe. If we are living in a simulation, our universe might be one of many running on a supercomputer. Each simulation could have its own unique set of rules, inhabitants, and history, but they all share the underlying feature of being digital constructs. This idea has profound implications for the concept of the multiverse. If simulations can create parallel universes, then the multiverse could be composed of an infinite number of simulated realities, each one running on a different computer or server. These universes could be interconnected in ways that we cannot yet comprehend, with some simulations interacting with others or sharing resources. The simulation hypothesis provides a new way to think about the existence of parallel universes, suggesting that they may not be physical at all, but instead digital constructs created by an advanced civilization. Fact 36. The concept of parallel minds and multiversal consciousness. The concept of parallel minds suggests that consciousness may not be confined to a single version of reality. In a multiverse, each possible decision or action creates a separate branch of the universe, but it could also create parallel versions of our consciousness. These versions of consciousness could share a similar subjective experience, but live out different versions of reality based on the choices made in each universe. For example, if you make a significant life decision, such as choosing a career or a relationship, the universe splits into multiple branches, each representing a different version of your life. Each branch would contain a parallel version of your consciousness, experiencing a different outcome. These parallel minds could be aware of their own existence, but unaware of each other, even though they share a common origin in the multiverse. The idea of parallel minds raises intriguing philosophical questions about personal identity and the nature of consciousness. If there are infinite versions of yourself in different universes, what makes you you? Are you defined by the specific experiences in your current reality? Or are you part of a larger, more complex network of parallel selves? The concept of parallel minds suggests that consciousness may not be as singular and isolated as we perceive it, but rather a multifaceted, ever-expanding phenomenon existing across an infinite number of universes. Fact 37. The interaction of parallel universes with dark energy. Dark energy is a mysterious force believed to be responsible for the accelerated expansion of the universe. While dark energy remains poorly understood, some theories suggest that it could be related to the existence of parallel universes. In a multiverse scenario, dark energy might be the result of interactions between our universe and other universes in the multiverse. One hypothesis is that the accelerated expansion of our universe could be caused by the influence of neighboring universes. If our universe is part of a larger multiverse, the energy from other universes could exert a gravitational effect, causing our universe to expand at an increasing rate. This could explain the observed acceleration of the universe's expansion, which has puzzled cosmologists for decades. Dark energy could also be a manifestation of the energy fields present in other universes. In this view, the multiverse itself could be a vast network of energy fields, each one influencing the expansion and behavior of the universes within it. As these universes interact, dark energy could be the result of these interactions, providing a link between the different universes in the multiverse. While this idea is still speculative, it opens up exciting possibilities for understanding the nature of dark energy and its connection to the multiverse. If dark energy is indeed related to parallel universes, it could provide crucial insights into the structure and dynamics of the multiverse. Fact 38. The role of parallel universes in quantum computing. Quantum computing, which harnesses the principles of quantum mechanics, is often associated with the concept of parallel universes. At the heart of quantum computing is the ability to process information in multiple states simultaneously, thanks to the unique properties of qubits, quantum bits. Unlike classical bits, which can be either 0 or 1, qubits can exist in a superposition of both states at once. Some researchers propose that quantum computers might actually be tapping into the many worlds of quantum mechanics to perform their calculations. In a quantum computer, when a qubit undergoes a transformation, it could potentially split into multiple parallel universes, each representing a different computational outcome. These parallel universes could each contribute to the final result of the computation, making quantum computers far more powerful than classical computers. This idea has sparked a debate about the true nature of quantum computing and its potential relationship with parallel universes. If quantum computers can access multiple universes simultaneously, it could explain their remarkable speed and efficiency in solving complex problems. While this theory is still speculative, it highlights the fascinating connection between quantum mechanics, parallel universes, and future technologies. Fact 39. The anthropic principle and the multiverse hypothesis. The anthropic principle is a philosophical consideration that seeks to explain why the universe seems so finely tuned for life. It argues that the conditions of the universe are not random, but are such that they support the emergence of conscious beings capable of observing those very conditions. The multiverse hypothesis offers a potential solution to this paradox by proposing that there are many universes, each with different physical laws and constants. In this context, the weak anthropic principle suggests that the reason our universe supports life is not due to its unique properties, but because we live in a universe that just happens to have the right conditions for life. In a multiverse, there could be countless other universes, many of which may be inhospitable to life. We observe our universe as life-supporting simply because we exist in it. This theory challenges the idea of our universe being special or unique. It suggests that life exists in our universe because out of many possibilities, we find ourselves in a universe with favorable conditions for life. This can be seen as a solution to the fine-tuning problem, the observation that the universe's fundamental constants, such as the strength of gravity or the mass of elementary particles, seem to be fine-tuned to allow for the existence of life. In a multiverse scenario, it's simply the case that life can only exist in universes where the constants are conducive to life, and we happen to live in one of those universes. The multiverse thus provides a framework where the fine-tuning of the universe is not a special occurrence, but rather the result of an ensemble of universes, each with different characteristics. Fact 40. The quantum multiverse and multiple versions of reality. The quantum multiverse is a concept that arises from the many worlds interpretation, MWI, of quantum mechanics. According to MWI, every quantum event that has multiple possible outcomes results in the splitting of the universe into several branches. These branches represent different versions of reality, each one corresponding to a different outcome of a quantum measurement. For instance, if an electron can be in one of two positions, the universe splits into two, each with a different version of reality, where the electron is in one of the two positions. This process, called quantum branching, suggests that there are infinitely many universes, each representing a different sequence of quantum events. This idea posits that every possible outcome of every quantum event occurs in a separate, parallel universe. For example, every decision you make, whether to eat cereal or toast for breakfast, creates a separate version of reality in which you made a different choice. In this quantum multiverse, all the possible versions of yourself and your life exist in parallel universes, each experiencing a different sequence of events. It's as if the universe splits into a multitude of parallel timelines, each representing a different outcome, allowing for an infinite number of realities, where everything that could happen does happen somewhere in the multiverse. Fact 41. The influence of parallel universes on the nature of probability. In classical probability theory, events are random and governed by the laws of chance. However, in the context of the many worlds interpretation of quantum mechanics, probability takes on a different meaning. In this framework, when a quantum event occurs, such as the position of an electron being measured, the event doesn't simply result in a single outcome. Instead, all possible outcomes of the event happen simultaneously, each occurring in a different parallel universe. This suggests that the concept of probability is not about predicting a single outcome in our universe, but rather about determining which outcome occurs in our particular universe. In other words, the universe splits into multiple branches, and each branch corresponds to one of the possible outcomes. From the perspective of an observer in our universe, it seems as though only one outcome occurred. But from the perspective of the multiverse, every possible outcome exists simultaneously in different realities. This challenges our traditional understanding of probability, as it suggests that probability is not about the likelihood of a single event occurring, but rather about the distribution of possible outcomes across an infinite number of parallel universes. The quantum multiverse allows all possible events to happen, but our universe only sees one outcome due to the nature of observation and measurement. Fact 42. the cosmological constant and the multiverse. The cosmological constant is a term in Einstein's equations of general relativity that represents the energy density of empty space. This constant plays a crucial role in the expansion of the universe, and its value is one of the most puzzling aspects of modern cosmology. If the cosmological constant were slightly different, the universe might not have been able to form stars, galaxies, or life as we know it. The fact that this constant is perfectly fine-tuned for life has led some scientists to propose that the cosmological constant could be the result of a multiverse. In the multiverse model, each universe might have its own unique value for the cosmological constant, and only those universes with the right constant would allow for the formation of life. This idea is sometimes referred to as the multiverse of constants. In this framework, our universe is just one of many, each with its own set of physical constants, and we happen to live in the one with the precise value of the cosmological constant that allows life to exist. The existence of multiple universes with different values for the cosmological constant could explain the apparent fine-tuning of our universe. While the multiverse theory provides an elegant solution to the fine-tuning problem, it remains speculative, and direct evidence for the existence of other universes is still lacking. However, the idea that the cosmological constant could be part of a larger multiversal structure continues to be an area of active research. Fact 43. The idea of bubble collisions and parallel universes. One of the intriguing aspects of the eternal inflation theory is the possibility of bubble collisions between parallel universes. According to the theory, the rapid expansion of the universe in the moments after the Big Bang caused bubbles of space-time to form, each one representing a separate universe. These bubbles could continue to expand indefinitely, and if they collide with each other, it could result in observable effects in our universe. The idea of bubble collisions provides a potential explanation for certain cosmic anomalies that cannot be explained by our current understanding of physics. For example, some regions of the cosmic microwave background radiation, CMB, exhibit unusual cold spots or fluctuations that some theorists suggest could be the result of a collision between our universe and a neighboring bubble universe. If two universes were to collide, their respective spacetimes could interact, causing ripples in the fabric of space and time that could leave detectable imprints in the CMB. These bubble collisions could provide evidence for the existence of parallel universes, as the effects of such collisions would be difficult to explain using only the laws of physics as they apply to a single universe. While the idea of bubble collisions remains speculative, it has sparked interest in the scientific community as a potential way to test the multiverse hypothesis. Fact 44. The simulation hypothesis and the multiverse. The simulation hypothesis, which suggests that our universe is a computer-generated simulation created by an advanced civilization, raises intriguing questions about the existence of parallel universes. If our universe is a simulation, it could be just one of many simulations running simultaneously, each representing a different parallel reality. These simulations could have different rules, histories, and physical properties, but they would all be generated by the same underlying computational framework. In the context of the multiverse, the simulation hypothesis suggests that the many parallel universes we hypothesize could be nothing more than simulations, each created for different purposes, such as scientific experimentation, entertainment, or exploration. The multiverse, in this view, could consist of an infinite number of simulated universes, each running on a different computer system or supercomputer. These universes would be indistinguishable from real life for their inhabitants, who would have no way of knowing they are part of a simulation. This idea challenges our understanding of reality and consciousness. If parallel universes are nothing more than simulations, does that mean our own universe is also an artificial construct? If we are part of a larger simulation, how does that impact our concept of free will, identity, and existence? While the simulation hypothesis remains highly speculative, it provides a novel way to think about the multiverse and raises fundamental questions about the nature of reality. Fact 45. The quantum multiverse and the nature of determinism. The concept of determinism, the idea that every event or state of affairs is caused by preceding events, is deeply intertwined with the theory of parallel universes. In classical physics, determinism is often seen as a cornerstone of reality. If we know the state of a system at one point in time, we can predict its future state. However, in quantum mechanics, the future is probabilistic, meaning that the outcome of an event is not predetermined, but instead governed by probabilities. The quantum multiverse offers a new perspective on determinism. According to the many worlds interpretation, MWI, of quantum mechanics, every quantum event that has multiple possible outcomes leads to the creation of multiple parallel universes. Each outcome occurs in its own branch of reality, meaning that all possibilities are realized. In this view, the universe is not strictly deterministic in the traditional sense, as every possible outcome exists in a separate universe, but each individual version of reality is determined by the events that occur within that universe. This challenges our conventional understanding of determinism, as it suggests that the future is not solely determined by past events, but rather by the interplay of quantum probabilities. In the quantum multiverse, the future is not a single path, but a vast array of branching possibilities, with each path leading to a different version of reality. This raises profound questions about the nature of free will and the relationship between individual choices and the multiverse. Fact 46. The quantum Zeno effect and parallel universes. The quantum Zeno effect is a phenomenon in quantum mechanics where the act of continuously observing or measuring a quantum system can prevent it from evolving. In other words, frequent measurements effectively freeze the system in its current state, preventing it from transitioning to other possible states. This strange behavior has led some theorists to propose that it could play a role in the creation and evolution of parallel universes. In the context of parallel universes, the quantum Zeno effect could explain how different branches of reality remain separate. Each time a quantum event occurs, the universe splits into multiple branches, each corresponding to a different outcome. The act of observation, or measurement, could cause these branches to remain distinct, preventing them from merging back into a single timeline. As a result, the continuous act of observation could freeze the evolution of each parallel universe, allowing them to remain separate and non-interacting. The quantum Zeno effect offers a unique way to think about the relationship between observation, measurement, and the multiverse. It suggests that the act of observing a quantum system not only influences its state, but could also play a role in the branching of universes, making it a key factor in the creation and stability of parallel realities. Fact 47. The role of parallel universes in explaining the fine-tuning of the universe. The fine-tuning problem is one of the most profound questions in cosmology. It refers to the observation that the physical constants and laws of our universe are perfectly balanced to allow for the existence of life. If the strength of gravity were even slightly different, stars and galaxies would not form. If the electromagnetic force were stronger or weaker, atoms and molecules would be unstable. This apparent fine-tuning has led scientists to wonder why the universe is so perfectly suited to life. One potential explanation for this fine-tuning is the idea of the multiverse. In a multiverse scenario, there could be countless universes, each with its own set of physical constants. Some of these universes would be inhospitable to life, but others would have the right conditions to support life. The reason our universe appears fine-tuned for life is simply that we happen to live in one of the many universes that has the right combination of constants. The multiverse theory, therefore, provides a natural explanation for the apparent fine-tuning of our universe. While the multiverse theory remains speculative, it offers a promising framework for understanding the fine-tuning problem. If there are countless other universes, each with different physical properties, then our universe's suitability for life is not a coincidence, but a result of living in one of the many universes with the right conditions. Fact 48. The concept of divergent timelines in parallel universes. One of the most intriguing aspects of parallel universes is the idea of divergent timelines. According to this concept, every decision, action, or event that can unfold in multiple ways causes the universe to branch into different timelines. These timelines are distinct and evolve separately, with each representing a unique version of reality. In essence, every possible outcome of every event creates a new universe where that outcome is realized. For example, consider a historical event, such as a major political decision or a personal choice, like deciding whether to take a particular job. In our universe, one outcome occurs, but in divergent timelines, other versions of reality emerge. In one timeline, you may have taken that job, while in another, you may have pursued a different career. Each of these outcomes is equally real, existing simultaneously in parallel universes. This concept of divergent timelines provides a compelling framework for understanding how every decision we make creates a new version of ourselves, living out different outcomes in different universes. It challenges the idea of a singular, linear timeline and suggests that reality is far more complex and multifaceted than we may have imagined. The notion of divergent timelines also raises questions about the nature of fate and free will, as it implies that every possibility is realized somewhere in the multiverse. Fact 49. The parallel universe and the fine-tuning of the laws of physics. The fine-tuning problem is one of the central mysteries of cosmology, addressing why the physical constants of our universe are so perfectly balanced for the emergence of life. The multiverse theory provides a potential solution to this puzzle. According to the multiverse hypothesis, there are countless universes, each with different values for the fundamental constants, such as the strength of gravity or the charge of an electron. In this scenario, the universe we inhabit is simply one of many, and we find ourselves in a universe that is fine-tuned for life because it happens to have the right combination of constants. If the multiverse is real, then the fine-tuning of our universe may not be as special as it seems. Instead of a single, unique universe where conditions are just right for life, The multiverse theory suggests that we live in a universe where the constants are suitable for life simply because there are many other universes with different values for those constants. Some of these universes may have no life or may be governed by radically different physical laws. The multiverse provides a natural framework for understanding why our universe appears to be finely tuned for life. It's because we are in one of the rare universes where life is possible, but other, equally real universes may not be conducive to life. Fact 50. Parallel universes and the concept of multiple realities. The idea of multiple realities is deeply connected to the concept of parallel universes. In the traditional view of the universe, we see one reality, one timeline in which events unfold. However, in a multiverse scenario, multiple realities coexist, each representing a different outcome of quantum events or choices made throughout history. These parallel universes exist side by side, potentially with different versions of ourselves, different physical laws, or different histories. For example, imagine a version of reality where World War II never occurred, or a reality where technological advancements happened centuries earlier. These multiple realities are not just theoretical constructs. In the framework of the multiverse, they exist as actual separate universes, each with its own history and future. Some versions of reality might be almost identical to our own, while others might be completely alien, with different laws of physics or even entirely different dimensions of space-time. The concept of multiple realities challenges our understanding of existence. It suggests that everything that could have happened in the past or could happen in the future is not only a possibility, but an actual reality, playing out in parallel universes. This also raises profound questions about the nature of identity, free will, and the choices we make, as it implies that every choice or event creates a branching reality, resulting in an infinite number of possible versions of ourselves and our world. Fact 51. The possibility of traveling between parallel universes. One of the most fascinating ideas related to the concept of parallel universes is the possibility of traveling between them. While still purely theoretical, the idea of traveling between parallel universes has been explored in both scientific literature and science fiction. If parallel universes exist, the next question is whether it would be possible to travel between them, accessing different versions of reality. One potential mechanism for traveling between parallel universes involves the concept of wormholes, which are theoretical passages through space-time that could connect distant regions of the universe. In a multiverse scenario, wormholes could potentially connect our universe to other universes, allowing for travel between them. These wormholes could be the key to exploring parallel universes, providing a bridge between realities with different physical laws, histories, or even dimensions. Another possibility for travel between universes involves quantum tunneling, a phenomenon in quantum mechanics, where particles can tunnel through barriers that would be insurmountable according to classical physics. If quantum tunneling can occur on a macroscopic scale, it might allow for the transfer of information or matter between universes. This would require advanced understanding of quantum mechanics and highly sophisticated technology, but it provides a tantalizing glimpse into the future of inter-universal travel. Though such travel is far beyond our current technological capabilities, the idea remains an exciting and speculative possibility. If parallel universes exist, future discoveries may reveal ways to navigate these separate realities. Fact 52. The multiverse and the role of dark energy. Dark energy is one of the most mysterious components of the universe, believed to account for the accelerated expansion of space. While dark energy's exact nature remains unknown, some theories suggest that it could be connected to the concept of the multiverse. In a multiverse framework, dark energy might not be a property of our universe alone, but rather a result of interactions between multiple universes. According to some models, dark energy could be the manifestation of forces from other universes within the multiverse. The idea is that the presence of neighboring universes could influence the expansion of our own universe, with dark energy serving as a bridge between these realities. If the multiverse consists of bubble universes, as suggested by eternal inflation, the interactions between these bubbles could be responsible for the effects of dark energy, such as the accelerated expansion of the universe. This idea opens up intriguing possibilities about the true nature of dark energy. Instead of being a force intrinsic to our universe, dark energy could be the result of our universe's relationship with other parallel universes. These interactions could be subtle and undetectable by current instruments, but they might hold the key to understanding the dynamics of the multiverse. Fact 53. The many worlds. Interpretation and its implications for free will. The many worlds. Interpretation of quantum mechanics has profound implications for our understanding of free will. In this framework, every quantum decision results in a branching of the universe, with each branch corresponding to a different outcome. This raises the question of how free will operates in a multiverse where every decision leads to the creation of a new parallel universe. One possibility is that free will is an illusion, and that every choice we make is merely one of an infinite number of decisions that lead to parallel universes. From this perspective, every version of ourselves is living out different outcomes of our decisions, and there is no ultimate you making the choices. Instead, each version of you is simply experiencing one of the many possible outcomes, each of which is equally real in its respective universe. On the other hand, some proponents of MWI argue that free will remains valid within the context of the multiverse, as the observer in each universe experiences the consequences of their choices, even if those consequences result in the creation of new universes. In this view, free will could be seen as the ability to choose between parallel realities, with each decision leading to the creation of a new universe, where a different outcome is experienced. While the question of free will in a multiverse remains a topic of debate, the many worlds interpretation offers a unique perspective on the nature of choice and agency in a universe that constantly branches into infinite possibilities. Fact 54. Parallel universes and the Fermi paradox. The Fermi paradox is the apparent contradiction between the high probability of extraterrestrial life in the universe and the lack of evidence for such life. Despite the vast number of potentially habitable planets in the Milky Way alone, we have yet to encounter any signs of intelligent life. One potential explanation for this paradox is the idea of parallel universes. In the context of the multiverse, it's possible that intelligent life exists in other universes, but for reasons beyond our understanding, we are unable to detect or communicate with them. These parallel universes could have different physical laws, dimensions, or forms of life that make them completely inaccessible to us. For example, an advanced civilization in another universe might exist in a reality where the laws of physics are so different that communication or interaction with our universe is impossible. The multiverse theory provides a way to explain the Fermi paradox by suggesting that the alien civilizations we seek may simply be located in universes that are physically separate from ours, with no way to detect or interact with our reality. In this view, the lack of evidence for extraterrestrial life might not be due to the absence of such life, but rather because it exists in parallel universes that we cannot access. Fact 55. The role of parallel universes in understanding quantum gravity. Quantum gravity is the field of physics that seeks to understand how gravity operates at the quantum level, where the laws of classical physics break down. The theory of parallel universes has important implications for the study of quantum gravity. Some theories, like string theory and loop quantum gravity, suggest that the fabric of space-time itself may be much more complex than we previously thought. In the context of parallel universes, quantum gravity could offer insights into how multiple universes could coexist within a shared space-time framework. If each universe in the multiverse has its own version of gravity, it might be possible for these universes to interact in ways that we do not yet understand. For example, brain world cosmology, which suggests that our universe exists on a three-dimensional brain within a higher dimensional space, could allow for the existence of parallel universes that interact gravitationally through higher dimensional forces. Quantum gravity could also help explain how space-time behaves at the smallest scales, where the effects of parallel universes might become apparent. If space-time is more complex than we currently understand, it could provide a way for multiple universes to exist simultaneously in the same space, each with its own set of physical laws and constants. While the study of quantum gravity is still in its infancy, the connection between quantum gravity and parallel universes offers exciting possibilities for our understanding of the nature of reality. Fact 56. The many worlds interpretation and the nature of identity. The many worlds interpretation, MWI, of quantum mechanics suggests that every quantum event leads to the creation of multiple parallel universes, each representing a different outcome. This raises intriguing questions about the nature of identity. In MWI, every decision or event creates a branching of the universe, leading to the existence of many versions of ourselves, each living in a different universe. These parallel versions of ourselves may experience different choices, events, and lives based on the outcomes of quantum measurements. One of the key questions that arises from this interpretation is whether our identity remains constant across these parallel universes. If there are infinite versions of ourselves living out different versions of reality, are we still the same person in each universe? Some argue that our identity is tied to the specific experiences we have in our universe, while others suggest that our identity is more fluid, with each version of ourselves representing a different, yet equally valid, manifestation of us. This idea challenges traditional notions of identity, suggesting that what makes us who we are might not be confined to a single version of ourselves in one universe. Instead, our identity could be seen as a collection of all possible versions of us, existing across multiple realities. This raises philosophical questions about the nature of personal continuity and the self, as it implies that there are multiple versions of you in parallel universes, each experiencing a different reality. Fact 57. The impact of parallel universes on the concept of free will. The concept of free will has long been a subject of philosophical debate, with questions about whether we truly have control over our choices or whether our actions are determined by factors beyond our control. In the context of parallel universes, the debate about free will takes on new dimensions. If every decision we make leads to the creation of multiple parallel universes, then it seems that every choice we make is not just an isolated event, but rather a branching point in an infinite number of realities. In this framework, free will could be viewed as the ability to choose which universe you experience, with each choice resulting in a new version of yourself existing in a different universe. Each version of you would be living out the consequences of the choices you made, but the other versions of yourself in different universes would experience different outcomes based on their own decisions. This interpretation suggests that free will is not about making a single definitive choice in a deterministic universe, but rather about participating in the creation of new parallel universes that each represent a different possible outcome. This view of free will as a multiversal phenomenon challenges the traditional notion of making a single, irreversible choice in a deterministic universe. Instead, it implies that every choice we make creates new realities, each one representing a different version of ourselves, living out the consequences of our decisions. Fact 58. Parallel universes and the concept of quantum tunneling. Quantum tunneling is a phenomenon in quantum mechanics in which a particle can pass through a barrier that would be insurmountable according to classical physics. This seemingly paradoxical behavior has led to speculation about its potential role in the formation and interaction of parallel universes. Some theorists suggest that quantum tunneling might provide a mechanism for the creation of parallel universes or for traveling between them. In the context of the multiverse, quantum tunneling could be the process by which a new universe tunnels into existence. For example, if a quantum fluctuation occurs, it could cause a localized region of spacetime to transition into a new, separate universe. This universe would then follow its own set of physical laws, distinct from the original universe. In this sense, quantum tunneling could be seen as the key to the creation of parallel universes, with each tunneling event resulting in a new branch of reality. Quantum tunneling might also allow for the possibility of travel between parallel universes. If two universes are close enough in terms of their physical properties, it could be theoretically possible for particles or even information to tunnel from one universe to another. This would provide a mechanism for interacting with or even accessing different parallel realities, although such travel remains purely speculative and far beyond our current technological capabilities. Fact 59. The possibility of multiple versions of Earth in the multiverse. One of the most fascinating implications of the multiverse theory is the idea that there could be multiple versions of Earth, each one slightly or vastly different from our own. These parallel Earths could exist in different branches of reality, each shaped by different historical events, physical laws, or environmental conditions. Some versions of Earth might have never experienced events like the extinction of the dinosaurs, while others might have evolved with entirely different forms of life. The idea of multiple Earths is a natural extension of the many worlds interpretation of quantum mechanics. where every event that could have multiple outcomes creates a new universe. For example, one version of Earth could be an exact replica of our own, where the only difference is that a single event, like a volcanic eruption or a historical decision, happened differently. In another universe, Earth might have evolved without the presence of human life, or the planet could be home to entirely different forms of intelligent life. These parallel Earths could offer a new perspective on the nature of our own planet, suggesting that the course of history and the development of life on Earth is not unique, but rather one of many possibilities. If multiple versions of Earth exist, it raises the possibility that humanity might one day encounter other versions of itself in alternate universes, potentially leading to fascinating discoveries about the nature of our existence. Fact 60. The role of gravity in connecting parallel universes. Gravity is one of the fundamental forces of nature, governing the attraction between objects with mass. Some theories in physics suggest that gravity may play a crucial role in the connection between parallel universes. In particular, the idea of higher dimensional gravity suggests that our universe could be part of a higher dimensional space, and gravity might be the force that links our universe to other parallel universes. One possible scenario involves the brain world theory, which posits that our universe is a three-dimensional brain existing within a higher dimensional space. In this model, gravity is not confined to our universe, but instead can leak into higher dimensions. This leakage of gravity could create interactions between different parallel universes, allowing them to influence each other. For example, if two universes exist within the same higher dimensional space, their gravitational fields could interact, causing subtle effects on the structure and evolution of both universes. The idea that gravity could be the force connecting parallel universes provides a potential mechanism for the interaction of multiple realities. If our universe is part of a higher dimensional space, it might be possible for gravitational effects to bridge the gap between different universes, creating a form of communication or interaction between them. Fact 61. The role of quantum fluctuations in universe. Creation. Quantum fluctuations are temporary changes in the amount of energy in a point in space, as predicted by the principles of quantum mechanics. These fluctuations are believed to be responsible for many phenomena in the universe, including the creation of particles and the formation of galaxies. Some theories suggest that quantum fluctuations could also play a role in the creation of parallel universes. In models of the multiverse, quantum fluctuations can cause the creation of new universes from nothing. According to the theory of eternal inflation, the rapid expansion of the universe in the moments after the Big Bang created regions of space-time that were sufficiently stable to form new bubble universes. These bubbles could emerge from quantum fluctuations in the fabric of space-time, each one evolving into a separate universe with its own physical properties and constants. Quantum fluctuations could also be the mechanism by which the Big Bang occurred. In this view, the birth of our universe was the result of a quantum fluctuation that caused a region of space-time to rapidly expand, forming the universe we know today. This idea suggests that the multiverse is constantly being created through quantum fluctuations, with new universes emerging from the quantum vacuum at an infinite rate. Fact 62. The interactions between parallel universes and dark matter. Dark matter is a mysterious and invisible substance that makes up about 27% of the universe. While we cannot directly observe dark matter, its presence is inferred from its gravitational effects on visible matter. Some theories in physics suggest that dark matter could be the result of interactions between parallel universes. In a multiverse scenario, dark matter might not be confined to our universe, but could be the manifestation of the gravitational effects from neighboring universes. If parallel universes exist in close proximity, their gravitational fields could overlap, creating the effects we observe as dark matter. In this view, dark matter would not be a substance within our own universe, but rather an influence from a parallel reality. This idea is supported by theories in string theory and brane world cosmology, which suggest that our universe could be part of a higher dimensional space where the gravitational effects of neighboring universes could manifest as a dark matter. These interactions between universes could provide an explanation for the mysterious nature of dark matter and its role in the formation and evolution of galaxies. Fact 63. The quantum multiverse and the nature of probability. The quantum multiverse theory, which arises from the many worlds interpretation, MWI, of quantum mechanics, suggests that every quantum event gives rise to multiple possible outcomes, each occurring in a separate parallel universe. This challenges our classical understanding of probability, as it implies that all possible outcomes are realized, rather than just one. In traditional probability theory, the likelihood of an event is determined by statistical measures. For example, if you flip a coin, the probability of landing heads or tails is 50%. However, in the quantum multiverse, the coin flip results in both outcomes: one universe where the coin lands heads and another where it lands tails. This means that every possible outcome of every quantum event occurs in a separate universe, making probability a measure of which outcome we will experience in our universe, not a reflection of which outcome actually occurs. This raises fascinating questions about the nature of probability and reality. In a quantum multiverse, probability is not about predicting a single outcome, but rather about determining which universe we will experience based on the possible outcomes of quantum events. This interpretation suggests that the multiverse is not just a theoretical construct, but a tangible feature of reality, where every possibility is realized in parallel universes. Fact 64. The simulation hypothesis and the limits of parallel universes. The simulation hypothesis proposes that our reality is a simulation created by an advanced civilization, and that everything we experience is part of a digital construct. If this hypothesis is true, it could have profound implications for the concept of parallel universes. In a simulated reality, the multiverse could be seen as a collection of simulations, each running on different computational systems. In this context, parallel universes would not be separate physical realities, but rather different simulated environments, each created by the advanced civilization that runs the simulation. These simulations could have their own unique laws of physics, histories, and inhabitants, and each one could represent a separate parallel universe. The boundaries between these simulated universes would be determined by the limitations of the simulation itself. The simulation hypothesis raises important questions about the nature of reality. If our universe is a simulation, then the multiverse could be a collection of simulations, each one a distinct reality running on a computer. This would suggest that the parallel universes we contemplate might not be physical at all, but rather digital constructs created by an advanced civilization. While this idea remains speculative, it provides a new way to think about the existence of parallel universes. Fact 65. Parallel universes and the nature of time. Travel. Time travel is one of the most fascinating and speculative aspects of the theory of parallel universes. According to certain interpretations of quantum mechanics and the multiverse, time travel may not involve traveling through a single, linear timeline, but rather through a network of parallel timelines or universes. In the many worlds interpretation, MWI, of quantum mechanics, every decision or event that could have multiple outcomes creates a new branch in the universe, each with its own timeline. If time travel were possible, it might not involve moving backward or forward in a single timeline, but instead shifting between different parallel universes. This concept, known as branching time travel, suggests that when you travel to the past, you don't alter the original timeline. Instead, you travel to a parallel universe that shares the same history up to the point of your arrival. But from that moment on, the timeline splits into a new reality. This raises important questions about the nature of causality and whether changes in one timeline would affect others. For example, if you traveled to the past in a parallel universe and made a significant change, would that new universe evolve differently from the original timeline, while the original universe remains unaffected? This framework allows for the idea of time travel without creating paradoxes, as each timeline remains consistent with its own history, and changes made in one universe do not ripple back to alter the past of others. Fact 66. The role of parallel universes in understanding quantum entanglement. Quantum entanglement is a phenomenon where two particles become interconnected in such a way that the state of one particle instantaneously affects the state of the other, regardless of the distance between them. This strange property has led to the idea that quantum entanglement might play a role in connecting parallel universes. According to some theories, entangled particles might exist in multiple universes simultaneously, with their states shared across different realities. In the context of parallel universes, quantum entanglement could allow for communication between universes, even if they are physically separated by vast distances. This would suggest that parallel universes are not isolated from one another, but could influence each other through entangled particles. If particles can be entangled across universes, it raises intriguing possibilities about the interaction between different realities and the potential for information transfer between them. The implications of quantum entanglement in the multiverse are profound. If entangled particles exist in parallel universes, it could mean that events in one universe can influence the state of particles in another, creating a form of cross-universal interaction. This could be a mechanism by which the universes in the multiverse are linked, even if they follow different physical laws or histories. Fact 67. The parallel universe and the concept of multidimensional space. One of the most fascinating aspects of the multiverse theory is the idea of multidimensional space, a higher dimensional space in which our universe is just one slice, or brane. According to brane world cosmology, our universe exists on a three-dimensional surface embedded in a higher dimensional space. This higher dimensional space, which may consist of more than the familiar three spatial dimensions, could contain multiple parallel universes, each existing in its own separate brane. In this framework, parallel universes are not isolated, but exist alongside each other within this higher dimensional space. Each universe could have different physical laws, constants, and dimensions. Some universes might be similar to ours, while others could be radically different, with entirely different laws of physics, allowing for the possibility of life forms that are completely alien to us. The interaction between universes could occur through gravitational forces or through the occasional collision of brains, creating new universes in the process. This idea of multidimensional space offers a compelling explanation for the existence of parallel universes, as it provides a mechanism for universes to coexist in a higher dimensional space while remaining separate and distinct. If our universe is just one brain among many, it suggests that the multiverse is much more vast and complex than we can currently imagine. Fact 68. The concept of invisible universes in the multiverse. One of the most intriguing ideas in the multiverse theory is the concept of invisible universes. According to some models of the multiverse, parallel universes could exist alongside our own, but be completely invisible and undetectable due to their physical properties or the fundamental nature of space-time. These invisible universes could be located in higher dimensional space or have completely different physical laws that make them inaccessible to us. For example, if parallel universes exist in dimensions beyond the 3 spatial dimensions we experience, they would be completely hidden from our perception. Even if these universes were close to ours in a higher dimensional space, their existence would be imperceptible because we do not have the ability to detect higher dimensions. In this sense, the multiverse could consist of countless universes, many of which we could never observe due to their lack of interaction with our reality. In some versions of the multiverse theory, these invisible universes could also have different laws of physics that make them fundamentally incompatible with our universe. For instance, a universe with a different number of dimensions or different constants could be entirely separate from ours, unable to interact with our reality in any way. These universes could still be real in their own right, but their invisibility would make them completely beyond our reach, remaining as hidden parallel realities. Fact 69. The influence of parallel universes on quantum computing. Quantum computing is based on the principles of quantum mechanics, and one of the most exciting aspects of quantum computing is its ability to process information in a fundamentally different way than classical computers. Qubits, the fundamental units of quantum computers, can exist in multiple states simultaneously due to the phenomenon of quantum superposition. This ability to represent multiple possibilities at once suggests that quantum computers might be able to tap into the concept of parallel universes. In a quantum computer, a qubit does not simply represent a 0 or 1, but can represent both values at the same time, thanks to its superposition. When a quantum computer performs a calculation, it essentially explores all possible solutions simultaneously, greatly increasing its computational power. Some researchers suggest that quantum computers could harness the power of parallel universes to process information, with each possible outcome of a quantum computation occurring in a separate parallel universe. This could allow quantum computers to perform calculations far beyond the capabilities of classical computers. While this is a highly speculative idea, it raises interesting possibilities about the relationship between quantum mechanics and the multiverse. If parallel universes exist, and quantum computing is based on the principles of superposition and entanglement, it is conceivable that quantum computers could leverage the existence of these universes to perform tasks that would be impossible for traditional computers. The power of parallel universes might be a key factor in unlocking the true potential of quantum computing. Fact 70. The cosmic inflation theory and the creation of parallel universes. The theory of cosmic inflation proposes that the universe underwent a period of rapid, exponential expansion during the first moments after the Big Bang. This expansion would have caused the universe to grow from subatomic sizes to vast scales in a fraction of a second. According to some models of inflation, this process could lead to the creation of bubble universes, distinct, self-contained regions of space-time that expand and evolve independently of one another. In this framework, the rapid expansion of the universe is not a one-time event, but a continuous process. As inflation proceeds, new bubbles of space-time form, each one representing a separate parallel universe. These bubbles could have different physical properties, such as different values for the fundamental constants, leading to the creation of universes with distinct laws of physics. Some bubbles might form universes with the potential for life, while others could remain barren, devoid of stars and galaxies. The idea of bubble universes is central to the concept of eternal inflation, which suggests that inflation is an ongoing process that continues to create new universes at an ever-increasing rate. This would mean that our universe is just one of an infinite number of universes, each with its own set of physical laws and properties. The theory of cosmic inflation provides a potential mechanism for the creation of parallel universes, offering a way for the multiverse to evolve and expand over time. Fact 71. Parallel universes and the evolution of life. One of the most profound implications of the theory of parallel universes is the idea that life could evolve in completely different ways in different universes. In our universe, life evolved under a specific set of physical laws and constants, such as the strength of gravity and the mass of elementary particles. These conditions allowed for the formation of stars, planets, and the emergence of life as we know it. However, in parallel universes, these constants could be different, leading to radically different forms of life, or no life at all. For example, in a universe with different values for the electromagnetic force, atoms might not be able to form stable structures, making life, as we understand it, impossible. In another universe, where the gravitational constant is much weaker, stars might never form, preventing the development of planets that could support life. Alternatively, in universes with more exotic properties, life could evolve in entirely different forms, perhaps based on entirely different chemical processes or using physical principles unknown to us. The idea of parallel universes offers an almost infinite variety of possibilities for life. It suggests that life is not a rare occurrence, but rather a possibility that could emerge in a multitude of ways, depending on the conditions of each universe. If parallel universes exist, then the evolution of life could be far more diverse and widespread than we currently understand. Fact 72. The role of parallel universes in understanding quantum mechanics. Quantum mechanics is the branch of physics that deals with the behavior of particles at the smallest scales, and it has long been a source of mystery and intrigue. The many worlds interpretation, MWI, of quantum mechanics offers a potential explanation for some of the strange phenomena observed in quantum systems. According to MWI, every quantum event that has multiple possible outcomes results in the creation of a new universe, with each outcome occurring in a separate branch of reality. This interpretation resolves some of the paradoxes of quantum mechanics, such as the famous Schrödinger's cat thought experiment. In the standard interpretation, the cat is both alive and dead until it is observed, at which point the wave function collapses to a single state. However, in the many worlds interpretation, the universe splits into two branches, one where the cat is alive and one where the cat is dead. Both outcomes are realized in different parallel universes. The many worlds interpretation offers a way to understand the probabilistic nature of quantum mechanics, suggesting that all possible outcomes occur in different universes. This provides a new perspective on quantum phenomena and may help to reconcile some of the more perplexing aspects of quantum theory. If the multiverse is real, it could offer a deeper understanding of the fundamental nature of reality and the role of observation in shaping the universe. Fact 73. The simulation, hypothesis, and parallel universes. As simulations, the simulation hypothesis, proposed by philosopher Nick Bostrom, suggests that our universe might not be the base reality, but rather a simulation created by a more advanced civilization. In this framework, parallel universes could be seen as different simulations, each with its own set of rules, history, and inhabitants. These simulations could be run by an advanced civilization for various purposes, such as scientific exploration or entertainment. In this view, the multiverse would not be composed of separate physical universes, but rather of simulated realities running on supercomputers or quantum processors. Each simulation would have its own version of space, time, and physical laws, and its inhabitants would be unaware that they are living in a simulated reality. The concept of parallel universes as simulations offers a new way to think about the multiverse, suggesting that all the possible realities we imagine could be nothing more than digital constructs created by an advanced civilization. This idea raises profound questions about the nature of existence and the role of consciousness. If parallel universes are simulations, what does that say about the true nature of reality? Are we part of a larger simulation? And if so, who or what is running it? While the simulation hypothesis remains speculative, it provides an exciting framework for considering the nature of parallel universes and our place within them. Fact 74. The role of dark matter in the formation of parallel universes. Dark matter is one of the most intriguing mysteries in modern physics. It makes up roughly 27% of the universe, yet its nature remains largely unknown. Some scientists hypothesize that dark matter might not be an intrinsic property of our universe, but could be the result of interactions with parallel universes. In this framework, dark matter could be the gravitational influence of nearby universes, which exist in higher dimensions or have different physical laws. According to certain models of the multiverse, the gravitational effects from other universes could manifest as dark matter in our own. If parallel universes exist and are located close to each other in a higher dimensional space, their gravitational fields might overlap and produce the effects we observe as dark matter. This suggests that dark matter is not a substance contained within our own universe, but is an influence from parallel universes, which we cannot observe directly, but can measure through their effects on visible matter. If this hypothesis is correct, it would radically change our understanding of dark matter and its role in the universe. Instead of being an unknown substance in our own universe, Dark matter could be a bridge to other universes, providing indirect evidence for the existence of parallel realities. Fact 75. The fine-tuning problem and parallel universes as a solution. The fine-tuning problem refers to the observation that the physical constants of our universe, such as the strength of gravity and the charge of the electron, appear to be precisely tuned to allow for the existence of life. If these constants were even slightly different, life as we know it would not be possible. This has led some scientists to propose that the fine-tuning of our universe could be explained by the existence of parallel universes. In a multiverse scenario, there could be an infinite number of universes, each with different values for the fundamental constants. Some of these universes might have the right conditions for life, while others might be inhospitable. The reason our universe seems so perfectly fine-tuned for life is simply that we live in one of the many universes where the constants are just right. The multiverse theory thus provides a natural explanation for the fine-tuning problem, suggesting that we are not in a uniquely fine-tuned universe, but rather in one of many universes that happen to have the right conditions for life. This solution to the fine-tuning problem challenges the idea that our universe is exceptional or unique. Instead, it proposes that our universe is just one of an infinite number of universes, each with its own set of physical laws and constants. The multiverse provides a statistical explanation for why life-supporting conditions exist in our universe. Fact 76. The potential for infinite universes in a multiverse. One of the most mind-boggling aspects of the theory of parallel universes is the idea that there could be infinite universes within the multiverse. According to various models of the multiverse, the number of universes could be limitless, each one representing a different combination of physical laws, constants, and conditions. The concept of an infinite number of universes challenges our understanding of reality, suggesting that the possibilities for existence are far broader than we can comprehend. The idea of infinite universes arises from the eternal inflation model, which suggests that the universe is constantly expanding and producing new bubble universes. In this framework, new universes are continually being created from the energy of inflation, each with its own set of properties. These bubbles could be as varied as our own universe, with some having the right conditions for life, while others might be hostile to any form of existence. The notion of infinite universes also comes from the many worlds interpretation of quantum mechanics, where each quantum event creates a new branch of reality. This branching process could continue indefinitely, leading to an ever-growing number of parallel universes. In this view, the multiverse is not just a set of alternate realities, but an infinite collection of universes, each one containing a different version of reality. Fact 77. The possibility of traveling between parallel universes. The idea of traveling between parallel universes is a common theme in science fiction, but it also raises fascinating questions in theoretical physics. If parallel universes exist, is there a way to travel between them? Some theories suggest that it may be possible to move between universes under certain conditions, using concepts like wormholes or quantum tunneling. A wormhole is a hypothetical passage through space-time that could connect two distant points in the universe. In the context of the multiverse, wormholes could potentially connect different universes, allowing for travel between parallel realities. If wormholes exist, and can be stabilized, they could provide a way to move from one universe to another, bypassing the vast distances of space. Quantum tunneling is another phenomenon that might provide a way to travel between universes. In quantum mechanics, tunneling occurs when a particle passes through a barrier that it classically could not surmount. Some theorists suggest that quantum tunneling could allow for the transfer of matter or information between parallel universes, effectively making inter-universal travel possible. While these ideas remain speculative, they offer exciting possibilities for the future of physics and the exploration of parallel worlds. Fact 78. The concept of cosmic bubble universes. The concept of bubble universes arises from the theory of eternal inflation, which proposes that the universe has been expanding exponentially since the Big Bang. In this model, inflation is not a one-time event, but an ongoing process, with new regions of space-time inflating and forming bubbles. Each of these bubbles could form its own independent universe with distinct properties, physical laws, and constants. The idea of bubble universes suggests that our universe is just one of many that exist within a much larger cosmic structure. These bubbles are created from fluctuations in the quantum field during the inflationary period, and each bubble evolves separately from the others. Some bubbles might have similar properties to our universe, while others could be radically different, with completely different physical laws, or even different numbers of dimensions. Bubble universes could also interact with each other, potentially leading to the creation of new universes or the transfer of energy between different regions of space-time. This idea supports the multiverse theory by suggesting that our universe is just one bubble in an endless sea of other universes, each with its own unique characteristics. Fact 79. Parallel universes and the search for extraterrestrial life. The search for extraterrestrial life has long been a focus of scientific research, but the existence of parallel universes could change the way we think about the possibility of life beyond Earth. If parallel universes exist, it's conceivable that extraterrestrial life might not just exist in our universe, but in others as well, potentially under entirely different physical conditions. In some parallel universes, the conditions for life might be very different from our own. For example, universes with different values for the physical constants could lead to the emergence of life forms based on entirely different chemistry or biochemistry. Life in these universes might not be carbon-based, as in our universe, but could involve elements or molecules that we cannot even imagine. Moreover, if parallel universes are connected by wormholes or quantum tunneling, it's possible that advanced civilizations in other universes could one day make contact with our own. The idea of inter-universal communication or travel could open up entirely new frontiers in the search for extraterrestrial life. If multiple universes exist, the question of whether life exists beyond Earth might be far more complex than we previously realized, with the potential for life in entirely different forms across the multiverse. Fact 80. The interaction of parallel universes and quantum mechanics. Quantum mechanics is the study of the behavior of particles at the smallest scales, and it plays a key role in the theory of parallel universes. According to the many worlds interpretation, MWI, quantum mechanics suggests that every quantum event that could have multiple outcomes creates a new universe for each possible outcome. This means that the act of observation or measurement causes the universe to split into multiple realities, each representing a different version of events. For example, in MWI, when a quantum event like the measurement of a particle's position occurs, the universe splits into as many branches as there are possible outcomes of the event. Each branch corresponds to a different reality in which one of the possible outcomes is realized. This leads to the creation of an infinite number of parallel universes, each with a different outcome of the same event. Quantum mechanics, and particularly the phenomenon of quantum superposition, forms the basis for many theories of parallel universes. In superposition, particles exist in multiple states at once until measured, at which point they collapse into a single state. In MWI, however, the superposition of states persists, with each possible state realized in a separate parallel universe. Fact 81. The role of energy in the creation of parallel universes. In some models of the multiverse, the creation of parallel universes is tied to the fluctuations in energy during the early moments of the universe's existence. According to the theory of eternal inflation, quantum fluctuations in the energy field during the Big Bang led to the rapid expansion of space-time, creating bubbles of space that could each evolve into separate universes. These bubbles are essentially regions of space-time with different physical properties, and they are continually being generated by the energy fluctuations in the early universe. Each bubble or parallel universe could have a unique configuration of physical laws and constants, which are determined by the amount of energy present in each universe. The EUTEI amount of energy in a universe could influence its rate of expansion, the types of particles that form, and the potential for the emergence of life. In this sense, energy fluctuations not only shape the universe we live in, but also provide the mechanism for the creation of multiple parallel universes. The energy fluctuations responsible for the creation of parallel universes may also explain the presence of dark energy, which is driving the accelerated expansion of our universe. If dark energy is a consequence of energy fluctuations from other universes, this could suggest that the universe we observe is part of a much larger and more dynamic multiversal structure. Fact 82. The multiverse and the role of higher dimensional space. The theory of parallel universes is often linked to the idea of higher dimensional space. According to theories like string theory and brain world cosmology, our universe may be just one of many that exist within a higher dimensional space. In this framework, each universe is confined to a different brain, a multi-dimensional surface that exists within a higher dimensional space. The interaction between these brains could give rise to new universes or cause the collision of existing ones. These higher dimensional spaces might allow for universes to exist in parallel, each with its own set of physical laws and constants. In this view, the multiverse is not just a collection of universes scattered throughout an infinite expanse, but rather a complex, multi-dimensional structure, with each universe occupying a different slice of higher dimensional space. These universes could be in close proximity to each other, yet remain completely separate due to their different dimensional properties. The existence of higher dimensional space provides a mechanism for the multiverse to operate, suggesting that the parallel universes we observe are not isolated, but instead connected by a larger, higher dimensional framework. This concept challenges our traditional understanding of space and time, suggesting that the universe we observe is only a small part of a much larger and more intricate reality. Fact 83. Parallel Universes in the Search for a Unified Theory of Everything. The search for a unified theory of everything, TOE, has been one of the most ambitious goals of modern physics. A TOE would provide a single framework that explains all the fundamental forces of nature: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, in a single theoretical model. Many physicists believe that the existence of parallel universes may be crucial to finding such a theory. In models like string theory and M theory, the multiverse plays a central role in explaining the fundamental forces and particles of the universe. String theory suggests that all particles are made of tiny vibrating strings, and these strings exist in multiple dimensions beyond the familiar three spatial dimensions. In M theory, there are 11 dimensions, and the multiverse arises from the different ways these dimensions can be compactified, leading to multiple possible universes with different physical properties. A unified theory of everything could incorporate the idea of parallel universes by showing how they emerge from the interactions of higher dimensional spaces or quantum fluctuations. If the multiverse exists, then the TOE might not just explain the forces within our universe, but also the mechanisms that give rise to countless other universes, each with its own unique properties. Finding such a theory would be a monumental step toward understanding the fundamental nature of reality and our place within the multiverse. Fact 84: the holographic principle and its implications for parallel universes. The holographic principle is a theoretical framework that suggests that our three-dimensional universe could be a projection of information encoded on a two-dimensional surface. This principle emerged from attempts to understand the nature of black holes, particularly regarding how information is stored in them. In the context of parallel universes, the holographic principle suggests that the multiverse could be composed of a vast array of holographic universes, each encoded on a higher dimensional boundary. According to this idea, each universe in the multiverse could be viewed as a hologram, with its entire reality being a projection from a two-dimensional surface. If multiple parallel universes exist, they could be connected in ways we cannot currently observe, as they may all share the same underlying information encoded on a higher dimensional boundary. The holographic principle offers a possible explanation for how the multiverse could function, where the fabric of space-time is not as rigid as it appears, but instead a dynamic projection of information. This principle challenges traditional ideas of reality and suggests that what we experience as physical space may not be the true essence of the universe. Instead, the true reality may be encoded in a much more fundamental, higher dimensional space. If the multiverse is holographic in nature, it could imply that we are living in a projection of a much larger and more complex structure, opening up exciting possibilities for understanding parallel universes. Fact 85: parallel universes and the limits of human perception. Our understanding of the universe is inherently limited by the human senses and the tools we have developed to measure the world around us. We perceive reality in three dimensions, and our understanding of time is linear. However, if parallel universes exist, our current perceptions might be limited in ways we cannot fully comprehend. These universes may be structured in ways that defy our understanding of space, time, and even causality, making them inherently undetectable by our senses. For instance, some universes might operate in more than three spatial dimensions, making them invisible to us. Other Universes could be governed by physical laws that are radically different from our own, making them completely imperceptible to the kinds of measurements and observations we can currently make. Our sensory apparatus is fine-tuned to perceive only the specific parameters of our universe, which means we are blind to the existence of other realities that might exist alongside us. In this context, the multiverse theory suggests that parallel universes could be hidden from our perception, even though they may be right next to us, operating in higher dimensions or through different physical laws. This raises philosophical questions about the nature of reality and whether human perception is capable of fully understanding the universe in its entirety. If parallel universes are indeed real, it is possible that we will never be able to directly experience them, as they might always remain outside the reach of our sensory experience. Fact 86. The simulation hypothesis and its role in parallel universes. The simulation hypothesis, which proposes that our reality might be a computer-generated simulation created by an advanced civilization, provides an intriguing lens through which to view the concept of parallel universes. In this framework, parallel universes could be viewed as different simulated realities running on separate supercomputers or quantum systems. Each simulated universe would have its own set of rules, histories, and physical properties, and these simulations could coexist as part of a larger computational framework. In the context of parallel universes, the multiverse would not be composed of separate physical realms, but rather digital constructs that are designed to simulate different possible realities. Each simulation could run independently, with its own version of space-time, laws of physics, and inhabitants. These simulations could be created for a variety of reasons, such as scientific experimentation, entertainment, or even exploration by the creators of the simulation. The simulation hypothesis suggests that all the parallel universes we imagine could be part of a vast, interconnected network of simulated realities. Each universe would be an artificial construct, running within a digital framework, and potentially designed by an advanced civilization far beyond our understanding. This raises profound questions about the nature of existence. If our universe is a simulation, what does that say about the other simulated universes in the multiverse? Could they also be part of a grand design? And if so, who or what is running the simulation? Fact 87. The role of gravity in the multiverse and parallel universes. Gravity, the force that governs the attraction between masses, plays a crucial role in our understanding of the universe. It is also central to many theories of the multiverse and the creation of parallel universes. In theories like brain-world cosmology, gravity is the only force that can leak into higher dimensions, allowing for the existence of parallel universes. According to these models, our universe could be a three-dimensional brain embedded in a higher dimensional space, and gravity could be the force that links our universe to other parallel universes. In this framework, each universe within the multiverse could be a separate brain with its own laws of physics, and gravity could be the force that allows these universes to interact. If multiple universes are located in a higher dimensional space, they might exert gravitational forces on each other, influencing the expansion or evolution of one another. This interaction between universes could lead to new universes being created, or to the merging of existing ones. Gravity's unique properties in higher dimensional spaces suggest that it could be the key to understanding how parallel universes form, evolve, and potentially interact with one another. The fact that gravity can transcend the boundaries of space-time makes it an essential component in the structure of the multiverse, linking separate realities in ways we are only beginning to understand. Fact 88: the many worlds interpretation and the concept of multiple realities. The many worlds interpretation, MWI, of quantum mechanics proposes that every quantum event results in the creation of multiple parallel realities, each corresponding to a different outcome. This interpretation of quantum mechanics suggests that every possible outcome of every quantum event exists in its own separate universe. In this framework, reality is not a single, deterministic path, but an ever-branching network of multiple realities, each existing simultaneously and evolving independently. For example, when you make a decision, say, whether to turn left or right at an intersection, each possible choice creates a new branch of reality. In one universe, you turn left, and in another, you turn right. These parallel realities exist side by side, with each one representing a different outcome of the same quantum event. The many versions of you in each universe experience different versions of reality, but they are all equally real, even though they may be completely unaware of each other's existence. This idea challenges our traditional understanding of reality, suggesting that the universe is far more complex and multifaceted than we perceive. The notion of multiple realities implies that every decision, no matter how small, results in the creation of a new branch of reality, and that every possible outcome exists somewhere in the multiverse. Fact 89: the multiverse and its impact on the laws of physics. The existence of parallel universes could have profound implications for our understanding of the laws of physics. In our universe, the laws of physics, such as the laws of thermodynamics, gravity, and electromagnetism, are well defined and govern the behavior of matter and energy. However, in a multiverse scenario, each parallel universe could have its own set of physical laws, which could be completely different from the laws we observe in our universe. For example, in some universes, the fundamental constants of nature, such as the speed of light or the gravitational constant, could be different, leading to completely different physical realities. In other universes, the laws of physics might be so different that concepts like space and time might not even exist in the same way. The multiverse theory suggests that our universe is just one of many, and each universe could have its own unique version of physical laws. This idea challenges the notion that the laws of physics are universal and constant across all of reality. Instead, the multiverse suggests that the laws we observe in our universe are just one possibility among many. Some universes might operate under entirely different rules, leading to an infinite variety of realities, each with its own set of governing principles. This diversity of physical laws in the multiverse could lead to entirely new forms of matter, energy, and even life, beyond anything we can currently imagine. Fact 90: the potential for life in parallel universes with different laws of physics. One of the most fascinating implications of the multiverse theory is the possibility of life existing in parallel universes with different physical laws. If there are infinite universes, each with its own set of physical constants, then life as we know it may not be the only form of existence. In universes where the laws of physics are different, life could evolve in completely unexpected ways, based on entirely different chemistry or physics. For instance, in a universe with a different number of dimensions or a different gravitational constant, atoms and molecules could behave differently, potentially leading to the emergence of life forms that are completely alien to our own. In universes with different physical laws, life might not be carbon-based, as it is in our universe, but could involve other elements or molecules that we cannot even imagine. Life could exist in forms that are entirely incompatible with the structures and chemistry of our universe. The idea of life in parallel universes with different laws of physics suggests that the potential for life is not limited to the conditions we observe in our universe. If the multiverse exists, then life could take on forms that are radically different from what we understand, based on entirely different principles of physics and chemistry. This opens up the possibility of discovering life in entirely unexpected forms in parallel universes, further expanding our understanding of existence. Fact 91: the quantum multiverse and its impact on the concept of reality. The quantum multiverse theory, which is based on the many worlds interpretation, MWI, of quantum mechanics, suggests that every quantum event creates a new parallel universe, leading to an infinite number of alternate realities. This theory has profound implications for the concept of reality itself. In the quantum multiverse, reality is not a single, deterministic path, but a constantly branching network of possibilities, with each decision or event resulting in the creation of a new universe. In this view, reality is far more fluid and multifaceted than our everyday experiences suggest. Each moment of decision or observation causes the universe to split into multiple versions, each corresponding to a different outcome. These versions of reality exist simultaneously, with each one evolving independently of the others. As a result, our experience of reality is just one of many possible versions, and the true nature of reality encompasses all possible outcomes. This challenges our traditional understanding of reality as a fixed, linear progression. Instead, reality in the quantum multiverse is a constantly branching tree of possibilities, with each version of reality representing a different path through the infinite network of universes. The quantum multiverse thus offers a new perspective on the nature of existence, suggesting that reality is far more complex and multifaceted than we have ever imagined. Fact 92: parallel universes and the nature of consciousness. One of the most intriguing aspects of the multiverse theory is its potential connection to the nature of consciousness. If parallel universes exist, each representing different outcomes of quantum events, this raises questions about the relationship between consciousness and the multiple versions of reality that could emerge from these events. According to some theories, consciousness might not be confined to a single universe, but could instead be spread across many different realities. In the context of many worlds interpretation, MWI, of quantum mechanics, every time a decision is made or an event occurs with multiple possible outcomes, the universe splits into parallel branches, each corresponding to a different outcome. If consciousness is tied to these branches, it would suggest that consciousness doesn't stay in just one version of reality, but instead shifts between parallel universes, experiencing all possible outcomes. This idea challenges traditional views of personal identity, suggesting that consciousness might not be confined to a single version of oneself, but is distributed across all the different versions of the self that exist in parallel realities. It implies that, in some sense, you are not just the person experiencing one timeline, but a conglomerate of all possible versions of yourself, each living out different lives in different universes. This raises profound philosophical and metaphysical questions about the nature of the self, free will, and the continuity of personal identity. Fact 93. The multiverse and the structure of space-time. The theory of the multiverse offers an entirely new way of thinking about the structure of space-time. In classical physics, space-time is viewed as a four-dimensional continuum that stretches across the entire universe. However, in a multiverse model, space-time is not a single unified entity. Instead, it can be divided into multiple regions of space-time, each representing a different universe with its own version of space-time. According to theories like eternal inflation and brain-world cosmology, the multiverse consists of multiple bubbles or brains, each of which is a separate universe with its own space-time structure. These universes may exist in a higher dimensional space, with each universe having its own version of gravity, space, time, and other fundamental forces. Some universes could be in close proximity to each other in this higher dimensional space, while others might be far removed, separated by vast distances that we cannot yet perceive. In this framework, space-time is not an all-encompassing entity, but rather a localized feature of each universe. The multiverse theory thus challenges our traditional understanding of space-time, suggesting that the very fabric of reality could be far more complex and varied than we currently understand. Fact 94. The role of quantum superposition in parallel universes. Quantum superposition is a fundamental principle of quantum mechanics that allows particles to exist in multiple states simultaneously until they are observed or measured. This principle lies at the heart of the many worlds interpretation, MWI, of quantum mechanics, which proposes that each possible outcome of a quantum event creates a separate parallel universe. In the context of MWI, quantum superposition is not merely a temporary state, but the basis for the creation of multiple realities. For example, when a quantum event occurs, such as the spin of an electron or the position of a particle, the universe doesn't collapse into a single outcome. Instead, all possible outcomes coexist, each one creating a new universe. This means that every quantum event that has multiple potential outcomes leads to the creation of a new branch in the multiverse, where each branch represents a different outcome of the event. Quantum superposition, therefore, provides a natural explanation for the creation of parallel universes. It suggests that every possible version of reality exists simultaneously, with each universe representing one possible outcome of the quantum measurements that occur in the multiverse. This challenges our classical view of reality, suggesting that the universe is far more complex and multifaceted than we perceive. Fact 95. The impact of parallel universes on our understanding of evolution. The theory of parallel universes also has the potential to change our understanding of evolution and the development of life. In our universe, evolution is driven by natural selection, where species adapt to their environment over millions of years. However, in a multiverse, the process of evolution could play out in many different ways, depending on the physical laws, constants, and conditions of each parallel universe. For instance, in a parallel universe with different values for the fundamental constants, the conditions for life might be entirely different. Life might evolve based on entirely different biochemical processes, or even different elements than those in our universe. In some universes, evolution might not occur at all due to inhospitable conditions, while in others, life could take forms that are radically different from what we can imagine. The idea of parallel universes challenges our understanding of evolution, suggesting that life is not unique to our universe, but could emerge in countless different forms across the multiverse. Each parallel universe could have its own version of evolution, with species adapting to the specific conditions of their respective universes. This opens up exciting possibilities for the study of life in the multiverse, including the potential for discovering forms of life that we cannot currently conceive. Fact 96. The role of parallel universes in solving the fine-tuning paradox. The fine-tuning paradox refers to the observation that the physical constants of our universe, such as the strength of gravity and the charge of an electron, are finely tuned to allow for the emergence of life. This has led to questions about why these constants are set in such a way, especially when even a slight change in their values could make life impossible. One possible solution to this paradox is the existence of parallel universes. In the multiverse scenario, there could be an infinite number of universes, each with different values for the fundamental constants. Some universes may have constants that are not conducive to life, while others, like our own, have the precise conditions required for life to emerge. The reason our universe appears so perfectly fine-tuned for life is simply that we happen to live in one of the many universes where the constants are just right. The multiverse theory provides a natural explanation for the fine-tuning paradox, suggesting that we are not living in a uniquely fine-tuned universe, but rather in one of many that happen to have the right conditions for life. This approach removes the need for a designer or creator, and instead provides a statistical explanation for the apparent fine-tuning of our universe. The multiverse theory suggests that life-supporting conditions are not unique to our universe, but are one possibility among many in the larger structure of the multiverse. Fact 97. Parallel universes and their connection to the concept of reality. The concept of reality has always been central to our understanding of the universe. However, if parallel universes exist, the very nature of reality could be far more complex than we have ever imagined. In a multiverse, reality is not a single, objective experience, but rather a collection of multiple, equally valid realities, each with its own version of events, physical laws, and histories. In this framework, reality becomes a far more fluid and dynamic concept, with each parallel universe representing a different version of reality. This challenges our traditional understanding of reality as a fixed, linear progression and suggests that reality is a constantly branching, ever-expanding collection of possibilities. Every choice, every event, every quantum measurement leads to the creation of a new version of reality, one that exists alongside the others. This raises profound philosophical questions about the nature of existence. If there are infinite versions of reality, how do we define the true reality? Is there a single, objective reality, or is reality subjective, shaped by the choices and events that unfold in each parallel universe? The idea of multiple realities challenges our understanding of existence and suggests that the universe is far more complex and multifaceted than we currently comprehend. Fact 98. The quantum multiverse and the nature of causality. In classical physics, causality is the principle that every effect has a cause, and events unfold in a linear cause and effect manner. However, in the context of the quantum multiverse, causality takes on a new meaning. According to the many worlds interpretation of quantum mechanics, each quantum event that has multiple possible outcomes causes the universe to split into different branches, each one representing a different outcome. In this framework, causality is still preserved within each individual universe. Each parallel universe follows its own chain of cause and effect events, with the history of that universe evolving independently of others. However, the branching of the universe means that causality is not a single linear progression across all of reality, but rather a series of distinct causal chains, each one unfolding in its own parallel universe. This challenges the classical view of causality, suggesting that the chain of cause and effect is not limited to a single timeline, but exists in multiple timelines, each one evolving according to its own set of quantum events. In the quantum multiverse, causality exists within each universe, but it does not necessarily apply across universes, as each universe is independent and follows its own causal structure. Fact 99. The simulation, hypothesis, and the creation of parallel universes. The simulation hypothesis, which posits that our reality might be a simulation created by an advanced civilization, raises fascinating questions about the creation of parallel universes. If we live in a simulation, it is conceivable that parallel universes could be simulations running on different computational systems, each with its own set of physical laws, constants, and histories. In this context, parallel universes would not be separate physical realities, but different simulated environments created by the simulators for various purposes, such as scientific experimentation, entertainment, or exploration. Each simulation could be designed to test different variables or scenarios, creating a multiverse of simulated worlds that are indistinguishable from reality for the inhabitants within them. The simulation hypothesis suggests that the multiverse is not composed of physical universes, but of digital constructs running on supercomputers. If our universe is a simulation, it raises the possibility that other simulations could exist, each with its own version of space, time, and physical laws. This view of parallel universes challenges our understanding of reality, as it suggests that everything we experience might be part of a digital program running within a larger system. Fact 100. The impact of parallel universes on the concept of ultimate reality. The idea of ultimate reality refers to the fundamental nature of existence, the essence of the universe that transcends individual perceptions and experiences. If parallel universes exist, the concept of ultimate reality becomes far more complex. In a multiverse, there is no single objective reality. Instead, ultimate reality could be the entire collection of parallel universes, each one representing a different version of existence. In this view, ultimate reality is not a fixed or singular entity, but rather an ever-expanding network of universes, each one with its own version of space, time, and physical laws. The true nature of ultimate reality may not be accessible to us, as we are limited to perceiving only the version of reality in which we exist. However, if the multiverse exists, then ultimate reality encompasses all parallel universes, each contributing to a broader understanding of existence. This idea challenges traditional metaphysical views, suggesting that reality is not a singular, absolute concept, but a multifaceted, dynamic system that includes countless versions of reality, each with its own unique qualities. The concept of ultimate reality, when viewed through the lens of the multiverse, becomes a vast, interconnected web of parallel worlds, each one contributing to the overall structure of existence.